this was written by a bunch of boomers trying to anticipate, like, they're like, this is what Zoomers want, right? And this comes off as entirely cringy the entire way through.
No fucking respect!
It's stupid, unlikable characters doing stupid, unlikable, like, making stupid decisions constantly. And they're like, this character's a genius. Jade is a genius and continues to make the dumbest decisions. And she's not rushed. She's not pressed for time. She's just like, you know what I'm gonna do?
You know how you hated her at the beginning, Alan?
Yeah.
And I said, that's not that bad. There's reasons why she hates her dad and she's a fucking asshole. She makes a decision in one of these episodes. I'm like, fuck you, I'm out.
Yeah.
Like, fuck, you're a dumbass. And Alex is right the whole fucking time, you piece of shit.
They like pull a knife on the dad and they like bash his brains in one scene. Like it's just
Not
like
even that. She gets other fucking innocent people killed for no reason. Like, we have a possible thing that can help in the zombie apocalypse, and you're gonna do it without anybody else. You're not gonna tell anybody else. You're gonna
security
get people on
team.
the ship killed on the. You're a fucking dumb asshole, bitch. Fuck that. I'm out. This is a piece of shit. So if your characters who you're supposed to be rooting for are pieces of shit that make the worst decisions at all times, I don't care. I don't care about the drama between Billy and Jade. I don't care that Billy is revealed to be a raccoon agent or a fucking umbrella agent where she is in charge secretly of everything, and she is the head of Umbrella. Right now, Billy is the head of Umbrella. That is stupid, and I hate it, and she's controlling the body. But Evelyn's still kind of there, so maybe Evelyn can get it back. I don't care.
We're gonna find out.
So at the end, turns out that Jade has a daughter. This guy's not a biological father, so we know where the daughter came from. Did she fuck around and create a clone as well, just like her father? Okay, fine. I guess that's season 2. I don't give a shit. But eventually, the daughter is just as fucking dumb as her mother, because for no fucking reason, at the end, when they're escaping on the ship and everything's great, the fucking daughter decides to fucking get off the ship and go back to the land. For why? Why again? Does anybody know why she left? She said so. Because she's an idiot, and she goes, and then the alligator comes to attack her, but then Billy shows up in the helicopter, shoots it, and then she captures Bae, or whatever her name is, B. So now Billy has Jade's daughter, and Jade has been shot in the gut, and that's how we end. And oh my God, is Jade gonna get her daughter back? What is Billy gonna do? And who is B really? And what can
she immune to zombies.
she's like, the alligator didn't fuck with her.
But the zombie breathing
But the zombie was chasing
her
down.
the first time.
Exactly.
It's just like, oh,
Maybe if she concentrates real hard, or she's shocked, then the zombie stops.
she shit her pants.
Maybe
Like,
it's just the
crocodile's like, I'm not
monsters.
eating that. You shit your pants.
Maybe it's just the monsters that stop, and not the zombies for it. It is inconsistent. You can tell that they are literally just making shit up as they go along, and I hate that. The guy wants to do 16 seasons. Motherfucker does not have a fucking plan. Doesn't. Before the season starts, okay, I got a proof of that. Let's write some stories of that. Pitch me some ideas. What's hot right now? Billy Eilish. Good. Let's throw that in. No, I'm fucking done with this.
Even if I give him the benefit of the doubt, you're like, oh, he has a plan. His plan is stupid. Because this season was stupid, and I imagine all of the next 15 seasons he wants to do will probably be equally as stupid.
And I don't want this to be an hour long, because I don't want to waste your time anymore on all this shit. So let's go final verdicts on the entire series. And then after that, we'll jump into each episode, do a little breakdown quickly, and give a rating for each one. So let's just up front tell you. 2. Holy shit! 2 out of 10.
Yeah, I agree. Fucking 2. I fucking hate the characters. I from the get-go, I was like, please do not have this back and forth timeline. I do not like this pace. This pace kind of takes you out of the immersion of what it's trying to do. But throughout the whole series, that's what it is. And I fucking hate it. I don't care about the characters. The characters continue to get dumber and dumber.
Yes.
And you don't care about the character development. And also, when maybe something cool happens, it's ruined by the songs.
Yes.
The songs.
Do you hate the songs as much as I do? We're not teenage girls, I guess.
They don't fit in.
There's no fucking Marilyn Manson seizure of power. There's nothing that feels
cool part in Lance dressing up as Blade with his fucking knife.
That's terrible. Joe,
That was
I like that they tried to go for it,
funny.
but it looks so bad.
It did.
And they even fucked it up.
But
It isn't even cool. I would forgive it when a motherfucker shows up in cosplay with his hair and
cleaning his glass.
I know, but that's all he does, and then he kind of moves a little quickly. It is so bad. It is not
okay,
as
no.
good as our other Wesker.
I don't care. That
Should've
gets
brought more.
that.
That guy way fucking better than that. When you're mimicking Wesker in that way, in the leather suit, you have to nail it. And he does, but they don't have competent cinematographers, action choreographers. They don't have nothing. And so it just looks like Lance in cosplay.
Lance is trying his heart out. All right, so I give him that. Then I saw that. It was so bad. It's good. It was so bad. I had to give it a point. I was like, I want to see.
I hate it.
I want to
So
see
bad it's good.
more of him.
So bad. And in the leather suit. You know what, Joe?
Yes.
If it was all just him in the leather suit, I would.
E.
No, no. Oh, we'll wait a little bit for a few more people to come in. I think we wait a couple more minutes and then we get kicked off. Yeah. Welcome, guys. You have arrived. Plus proche. Ouais, test. All right, I think maybe we can get kicked off. So, hey everybody. Hey. So happy Friday. My name is Ernest Aupetit. I'm friend of Seb's. I'm helping today with animating, organizing this stage, introducing our speakers, making sure they submit their slides, that kind of thing. In my day job, I'm leading product at Kiln. We are a staking platform, primarily focused on Ethereum, but we're getting involved in Cosmos more and more, so super happy to meet a lot of you today. But yeah, my job really is MC today. We have lots of awesome talks today on the Builder stage. I think there's like 8 talks and 2 panels, so there's a lot going on. You'll see the agenda on nebular.paris/agenda, and yeah, so please tell your friends to come here. This is where it's happening, right? It's the Builder stage. And to kick things off, we have Susannah Evans, who's right here, who will take us through IBC. So. Sorry, 1 second. Let me get my notes. So Susannah is the IBC product lead at Interchain GmbH. And in her talk, she's going to talk about how IBC works, explore use cases beyond cross-chain token transfer, and how this protocol can be used beyond Tendermint-based chains. So please join me in welcoming Susannah to the stage. Can we get the slides up, please? Perfect, thanks.
Okay. I'll just wait for my glass of water.
Lovely mint inside.
Thank you. Okay. Hi everyone. So yeah, thank you for joining and coming to my talk. So as I was introduced, I am currently working as the product lead at Interchain, and our team is working on the IBC specs and the Go implementation of IBC. So today I'm going to talk about IBC, the Inter-Blockchain Communication Protocol. I'm going to give an overview of how it works, how it's used, and how it can be used beyond Cosmos. And then I'll just wrap everything up at the end. So yeah, we're going to start by looking at this very beautiful picture. This is a port in Marseille in the 1700s. And as you can see, there's people kind of loading barrels onto ships, offloading sacks of grain. And it's quite chaotic. There's a lot going on. All of the cargo has a different shape. And there's kind of no unified way to put stuff on and off the boats. And if we fast forward to the 21st century, we can see that this is a typical port. This boat is completely optimized to hold as much cargo as possible. There's cranes which are dealing with the loading, so they handle the cargo, taking it on and off the ship with ease. And the reason why it's improved so much since the 1700s is because of this shipping container. And the shipping container is a global standard in the shipping industry. It has a standard size, dimensions, and this means that it can be used in all ports interchangeably. All of the cranes are compatible with these containers, and it doesn't matter what's inside the containers. You can move anything from A to B really easily because of this standard. So yeah, if we go back to Marseille, they had, for instance, wine in barrels and grain in sacks. If you had these shipping containers, you could also be transporting the wine and grain, and it just fits nicely into these containers. So, yeah, why am I talking about shipping? So it forms a kind of nice analogy for IBC. And so IBC, if you didn't know, is a interoperability protocol to allow blockchains to communicate with one another. And in terms of the shipping analogy, you can think of the blockchains as ports, relayers, who are actually responsible for sending the messages from A to B. You can think of that as the boats going between the ports. And the closed shipping container, which has standard dimensions and means that all the cargo is going to be transported in a standardized way. You can think of this as the transport layer in IBC. And when you actually open the shipping container and you see, oh, there's like wine or grain inside, you can think of this as the application module in IBC. So once you know what's inside the shipping container, you'll do specific actions based on what you have. So then if we look in a bit more detail into each of these components, here is a high-level depiction of how IBC works. So you have two blockchains, blockchain A, blockchain B, that are trying to communicate with each other. And they have an application module, and this interfaces with the transport layer. And the relayers are responsible for ferrying messages between blockchain A and blockchain B. And important to note is that anyone can be a relayer. So this is what makes IBC a permissionless protocol. In theory, you could relay your own messages between the two blockchains that you want to communicate between. So if we look in a bit more detail at what's going on in the transport layer, the nice thing about IBC is that you split up the transport layer into these three components. And the top layer are the channels. So the channels are what interface with the applications. And this is nice because if you're an application developer, you only need to be concerned with what's going on with these channels. Everything else in the transport layer is not really relevant for your specific purpose. And so these channels are where data packets are sent over. And every channel has a port ID and a channel ID. And the port ID is identifying the application that this channel is intended to be used for. And the channel ID is just a unique identifier for this channel. Because it's important to note that one channel has a single application for it. So for instance, if I wanted to send Atom from the hub to Osmosis, this would be through one channel. And for a single token denomination, there would be one channel as well. So you wouldn't have multiple channels sending Atom. There would just be one channel that's dedicated to sending Atom between the hub and Osmosis. And these channels can be ordered or unordered. So it either matters the time that the originating message was sent or it's irrelevant. And in this example that I've just picked out just to demonstrate the naming and a use case. So if I wanted to send Atom from the hub to Osmosis, the port ID would be transfer to show that it's a token transfer, and the channel ID is 141. And if I was sending Atom from Osmosis to the hub, the port ID would also be transfer, but the channel ID is 0 in this case. So the next level of the transport layer are the connections. And between two blockchains, you would have one connection, but then there can be as many channels as you want built on top of this one connection. And the connection is there to verify that the chain that you're communicating with is as you expect it to be. So there's a connection handshake that will take place between the two blockchains. And then once the connection is established, it's responsible for all of the communication between these two chains. And then the clients are arguably one of the most important parts of the transport layer in IBC. It's the way that means that you are sure that messages are actually being sent to you. So the blockchain A would have a client of the blockchain B that it's trying to communicate with. And with this client, it can check that a message was actually sent from blockchain B. And this means that the IBC protocol has security in line with the underlying chain's consensus mechanisms. There's no kind of trusted third party in that sense. So it's really trust minimized, dependent on the underlying chain's consensus mechanisms. And relays are responsible for updating these clients. So they will submit block headers to the clients, and then this will be used to verify the consensus state of the counterparty chain. And relays can also submit misbehavior if they think something is either there's like a hard fork or some misbehavior. They can also submit this to the client. And then what's actually being sent between the chains are the packets themselves. And this is going back to the kind of analogy I said with the shipping container. So the packets are sent in standardized format. So you have information on the origin of the packet and the destination, and then you have a timeout height and timeout timestamp associated with it. This is so that if a packet does not reach its destination as it's expected, you wouldn't lose, say for instance you were sending tokens, you wouldn't lose them forever. The transaction would be reverted and your tokens would be refunded. And then within this shipping container, there's data in the form of bytes, and it's the responsibility of the application module to decode these bytes and perform whatever action is intended to be performed. So it could be a token transfer or a cross-chain query or whatever the application is intended to do. So for the protocol to function with a successful packet send, this is the kind of flow that a packet would take. So a user would interact with the application. They would then send the packet to the transport layer, and then the relay would query this packet. They would then pass this packet on to the receiving blockchain, and then once the receiving blockchain has received the packet, the application module on the receiving blockchain will then carry out whatever logic that application needs to function. And then they will send an acknowledgement back, and the relay will ferry this acknowledgement back to the sending blockchain. In the case where the packet wasn't received by the other blockchain, so blockchain B doesn't actually end up getting the packet that was sent, the relay would query the core IBC on the receiving blockchain. They would say, oh, this packet wasn't received. Then they would send this timeout back to the sending blockchain to let the blockchain know that the packet never got there. And that's kind of a summary of how IBC works. But the reason it's such a powerful protocol and why it forms this standard for cross-chain communication is there are three main elements that make IBC such a powerful interoperability protocol. So the first is the security. As I mentioned with the light clients, you're trusting the underlying consensus mechanism of the blockchains that you're trying to communicate between. And there's also fault isolation built into the IBC protocol. So if there is some misbehavior detected, this light client would just shut down and stop sending messages between the chains. And this is really important just to stop the spread of foul behavior, which could have a much greater impact if it went beyond a single chain. IBC is also permissionless, so anyone can relay packets between chains. You don't have to have a specific person. You don't have to be whitelisted. There's no restriction on who is able to actually ferry these data packets between chains. And IBC is also generic enough to enable general message passing. So it's not just about sending tokens between chains. There's a whole other host of functions that you can use IBC for. And because of these factors, this is what makes IBC a really powerful interoperability standard. And IBC was launched just over a year ago. And there's a nice graph here which demonstrates the growth IBC has seen. So it's been exponential growth. Really, it's a very fundamentally used protocol within the Cosmos ecosystem. Right now, there are 48 chains that are connected and using IBC. And in the past 30 days, there were over 2.5 million transactions, and in value that was transferred, $330 million US. So it's great to see that this protocol has had such great utilization and growth, and it's only been around for a year. So yeah, I've talked a bit about how IBC works, but I haven't really touched on any of the applications. And I said that it could enable general message passing, but the main use case so far has been token transfer. That was kind of the first, essentially, like go-to-market of IBC. And you can do token transfer today with IBC using either the Interchain standard, or you can actually do token transfers using CosmWasm smart contracts. There's also an example of a more general data transfer using IBC. So the Band protocol is a decentralized Oracle network, and they are actively sending out Oracle data to blockchains in the Cosmos ecosystem. And Injective created a custom application to actually send and receive this Oracle data. So they're mainly using it for price feeds. And these are just two use cases which are live and happening frequently today. But there's a whole host of other things which are currently under development. So Interchain accounts has been launched as a feature, but chains are just still working on implementing it for their specific use cases. It's basically a way to do a cross-chain write, so perform an action on another chain originating from a chain that basically, say you're on blockchain A, you can then perform an action on blockchain B. And so, for instance, example you could use this functionality for is cross-chain voting. So the hub could vote on a governance proposal on regen, for example. Another cool feature which is being developed by a few teams is interchain queries. So this is a cross-chain read. So Quicksilver are developing a interchain query application module. And for instance, a use case for this module could be to check the delegations of an account. So see what one account is delegating their tokens to on another chain. And there's also NFT transfer that's been developed by IrisNet. So this would enable you to send NFTs between two blockchains. So for instance, you could send your NFT from Iris to Stargaze, or OmniFlix also use NFTs. And all of these examples that I've kind of given so far have been very Cosmos focused. But IBC can and is in the process of going far beyond Cosmos. So currently the out-of-the-box light client implementation is the Tendermint light client. So that's what all of the Cosmos SDK and Tendermint-based chains are using to plug into the IBC protocol. And they're using the IBC Go implementation. But this is just kind of the first use case. So Composable are developing 2 light clients to extend the reach of IBC. The first one that they've developed, and it will be going live, I think, in this quarter, is the Beefy light client. So this would connect Cosmos with Parachains in Kusama and Polkadot. And they're also started work on a Near light client. So this would enable us to connect to the Near ecosystem. And there's also enterprise applications of IBC. So Hyperledger Besu has a light client for their proof of authority-based consensus mechanism. So yeah, these are just 4 examples of IBC being developed for use outside of the Cosmos ecosystem, which I think is really exciting and really reinforces this notion that IBC can be a cross-chain communication interoperability standard. And beyond just light client implementations, there are also other ways that you can access this interoperability standard that IBC offers without having to make a light client. So for instance, SIFT chain uses peg zones, which is a way to basically interface with blockchains with different consensus mechanisms to your blockchain. So it kind of just acts as a buffer to make sure that there's for instance, Ethereum has probabilistic finality, so the peg zone has adequate delay to make sure that you can verify that what's happened on Ethereum is actually going to be final. And then the solo machine case is just another way to verify a state, but it's using like a key value pair signing. And Crypto.com use this to mint DOT. So they're a custodial chain, and they buy DOT themselves, and then they use an IBC solo machine to mint DOT that can then be used on their Cosmos SDK chain. So yeah, just to summarize everything that I've spoken about, I'm really bringing this analogy back of IBC being this interoperability standard. It's a secure way for chains to communicate. It's permissionless, and it enables a really big range of applications through this general message passing ability. And as I mentioned, IBC is not just for Cosmos. That was definitely the first use case and implementation of the protocol, but it's already starting to have reach much further than just Cosmos. And if you're interested in the Interchain accounts feature that I mentioned, Thomas, our developer relation, is going to be giving a presentation and demo at 5:25, I think, in the workshop room. I would have to double check. But yeah, you should check it out if you're interested. So yeah, thank you for listening to my talk. And yeah, this guy is just wishing IBC existed back then.
That was awesome. Congrats. We have time for questions, and with some beautiful mics here. Does anyone have a question for Susannah?
Yeah, it's a simple question. I was wondering if you send a token with IBC from chain A to chain B, then from chain B to chain C, and then from chain C back to chain A, do you get the original token back, or is this like some splitted liquidity?
No, so that basically, when you do this, it would have the path going A to B to C and then C to A. So you'd actually have to unwind it down the path.
Is that something that might be changed?
Yeah. So I think there's kind of talks to possibly implement some middleware which could unwind tokens. So then it would become like equivalent to the native token that it came from on chain A. But yeah, currently it would have a different.
Any timeline for this, or just talks?
I think it's actually something that we've been thinking about. Thinking about if the Interchain standard 20, so this is token transfer, should maybe be changed, and generally like middleware, which is going to then probably be used for lots of token transfer use cases. So token fungibility is like a big general topic that is like discussed, and of course it's like a key question. So I think it's something that we're thinking about, but I can't put like a timestamp on. It's not going to be in this quarter, but possibly Q4, something like this.
Yeah. I think this one works well.
So what happens with a contentious hard fork?
So if the light client was updated and there was a discrepancy between the previous update, and it saw like, either there's a discrepancy in the timestamp of updating the client, or you have a consensus state for the client which has information on the block header and the validator hash. So if there was some discrepancy, you set like the every client sets their own like parameters as to how like far this discrepancy would be, then the client would just shut down. So yeah, this is like a fault isolation mechanism. If there's something that looks wrong, yeah, the safest thing to do is just to say, I don't want to communicate anymore or deal with this.
Any final questions? Okay, cool. Thanks so much, Susannah.
Thank you.
Feel free to take a seat for people who just arrived. And a housekeeping note, we're supposed to enter from there, not from there. That's what I was told to say. So come in through the balcony. Yeah, thanks. Check. Okay, everyone, please get settled in. We're going to get cracking for the next talk. So, yeah, so as our next talk, we have Jakub Wojciechowski. I'm trying my best to pronounce your last name. Jakub is going to talk to us about modular smart contracts on Arweave and a lazy evaluation pattern design. So Jakub is the CEO founder of Redstone. And yeah, please give him a warm welcome to Jakub. Can we please get the slides up? Thanks.
Awesome. Hi guys, thanks for coming to learn more about the modular smart contracts on Arweave. And for those less familiar with Arweave, obviously it's like a Cosmos-focused conference, so let me give you a bit of a background about the Arweave storage network, which is a blockchain that is focused purely on data storage, and it gives you a really strong guarantee of the persistence of data. So once you put in information on Arweave, it's going to be stored permanently. Obviously, it's a really bold statement, but it's based on the assumption that the storage cost, the hardware storage cost, will drop by half every 2 years. So whenever you put data on the Arweave, then part of the funds will go to the endowment fund that will sponsor the storage for all of the node operators. But there are some, let's say, issues with a new model and the focus on the storage that in order to properly see it and validate the data availability, the block time is not as you may expect from other chains. It's a bit slower, and also indexing a humongous amount of data. It's not a trivial task, but fortunately there are new solutions coming up in the space. And in my view, it's really important to take, let's say, non-standard approach in the blockchain development when all of the L1s and L2s are focusing on the throughput, on scaling the number of transactions that can fit into block, often forgetting about the data volume. And that's kind of an elephant in the room, as most of the blockchains cannot deal with a full state and full storage support. And why are we building on Arweave and developing smart contracts there? So we started as an Oracle company with a twist that we do not put the data directly on the targets chains, like the EVM chains, like Ethereum, Avalanche, Celo. We keep all of the information directly on Arweave, which is much more affordable. And also we pass the information through meta transaction, which allows us to interact with almost every EVM compatible chain without making any amendments in the code. As I mentioned, we keep the data on the Arweave, but we needed an extra layer of business logic, mostly to manage data access. So data providers can adjust their manifest, specifying what kind of an information is going to be submitted. That can also amend the aggregation logic. All of the metadata is being managed by the smart contracts on Arweave, so it's like fully transparent to the users. And it's very important to maintain the data integrity. So all of the usual Oracle solutions with dispute resolution, when you can claim that the data is inaccurate and get some kind of a refund, it's also implemented using the smart contracts. And obviously the most important part is how actually incentivize all of the data providers to feed high quality data. And that's been done with the help of tokens, which are also powered by the smart contracts on Arweave. And with oracles, at the moment, we got more than 3.5 billion data points fully persisted on Arweave, and the infrastructure is being managed by the smart contracts. So when we realize we need something more than just purely storage, we look into the original SmartWeave idea, which was brought up by the core Arweave team. And it's a very simple idea to separate the code, the interactions from the actual state. So you only persist the bare minimum, the smart contract code and all of the inputs to transactions. But the state is something ephemeral that could be always recomputed from scratch. Therefore, you get amazing flexibility, but also the part that the state can always be evaluated is a tricky one. So it looks great on a paper, but when we started playing with that and work with many projects that were taking the original SmartWeave concept, we ran into a lot of issues. So the more popular use cases were actually taking a pretty long time to evaluate. So it's a very naive assumption that you can always recompute the full state, that every user will become a full node. And one of the projects that we started working with and trying to improve, so the contracts were taking 2 days for the full evaluation, which was obviously a no-go for the current state of the SmartWeave. And we started improving that step by step. So the main issue was obviously the fact that all of the contracts needed to fetch the data directly from Arweave, from this humongous storage chain. And obviously you got the usual issues of the data transfer and also extracting from multiple nodes. And that was taking a long time to evaluate. So we quickly implemented a few fixes. The first one was something we call warp cache, which is a cache around the node or a client evaluating contract transactions. And it obviously helps to limit a number of outgoing requests to the base Arweave layer. And we also built an indexing layer, we call it gateway, that listens to the changes to the Arweave storage, picks only the SmartWeave transactions, and then offer a proper indexing for faster queries. So this helped us a lot to cut down the evaluation costs. But there were other issues that we encountered. So it's really important for a major smart contract environment to offer the cross-contract calls. And that was tricky in the original version of the SmartWeave, which relied on something called a foreign calls protocol. And whenever you wanted to communicate between two contracts, you need to create a third intermediary contract and then persist there all of the requests to write or read data. And that's an interesting design, but you got a few flaws from the point of view of transactionality, but also from the point of view of efficiency of the state evaluation. So we decided to get rid of this pattern and replace it with our own methodology. We call it like predict and verify method. So whenever we see in a contract a possibility that another contract will be invoked, and we do it by making a run with a smart contract. It's something very similar to a gas estimate in Ethereum. Then we create a path of execution, and we persist that path of execution in the transactions. And whenever that path of execution is being actually evaluated by a client, we check if the assumptions were accurate, because obviously something may happen in the middle. And if it's fine, then we allow to evaluate the contract. And that's much more efficient. Obviously, you get a possibility to have like a synchronous multi-contract call, like contract I, calling contract B, and from contract B, contract C, and even back to contract I. That's perfectly fine. Also, the basic smart with contracts were mostly written in Java or TypeScript, and obviously that's not the most secure environment to execute, let's say, production-ready contracts, as you are risking any possibility of hijacking the environment of the client executor. That's why we decided to sandbox the execution into WebAssembly. And apart from the security, we obviously got a really significant speed improvement, and we get the ability to execute contracts written in multiple languages out of the box. So we got a full support for assembly script and Rust. Rust is like the most popular language at the moment, and we also support Go for that. And that's the next step in our evolution, because having a WASM abstracted runtime environment allows us to introduce metering and to manage the transactions in a more meaningful way, so we can calculate what were the cost of execution and then offer evaluation of smart contract as a service. Another issue with Arweave that I mentioned at the beginning was the fact that the time of mining a block, it could be quite long and significant, because sometimes when there is a lot of data, there is a need to have a lot of checks before it could be included in the block. That's connected with the block width consensus model, when you need to present a proof of data probing before being able to write a block into the network. So sometimes this process can take up to a few minutes, and that's definitely not reasonable for end users to interact with the smart contracts. So we integrated with another project in the Arweave ecosystem called Bundler. And Bundler is a really useful service that allows you to get a commitment, a guarantee of data seeding immediately, and then Bundler and their nodes are responsible to deliver the data to the network, taking care of all of the possible network forks and delays resubmitting the data. So we rely on the Bundler guarantees, and that allows us to index the incoming transaction much faster. Obviously, as I mentioned, that the possibilities of fork and the delay, we cannot rely on the final placement of transactions in the block. We needed to add a service that intercepts the transactions sent by users before they go to Bundler and introduce a sequence, deterministic predictable sequence. It's very similar to what happens in the rollup networks. So we need to order the transactions for a proper evaluation, and that's why we introduced this service. Obviously, currently it's centralized, but at least we get a few ideas to make it like blind, so we cannot censorship the transactions incoming. We just verify the hash, and then later on when the order ID is attached, we can pass that transaction further. And as I mentioned, SmartWeave was relying on the assumption that everyone and every user can become a full node. That's very important to have the possibility of everyone to check the full history of transaction, but that's also not very efficient if you are addressing the mass adoption. So we decided to create something we call distributed execution network, when we get the technology to spin off a few nodes that will listen to the subset of transactions that happen between the contract that you are interested. You may think about it as a application-specific subnet that will evaluate only this part of the transactions and give you an access to the evaluated state much faster in the real time. And at the moment, we use a random probing, like a few sessions of querying the nodes and aggregating the data, so it's like super lightweight. But at the moment, it's not incentivized. So we offer that as a solution to all of the projects that are building on the Arweave network to faster evaluate the state and offer that to the users. But what we are really thinking about is building an incentivization layer that I will talk later on. So to summarize everything that I've been trying to explain, we can take a look at the typical transaction lifecycle in our Warp ecosystem. So whenever a user sends a transaction, it goes to sequencer to receive an order. So we can know how it relates to other transactions received by the network, then being seeded by bundler, and bundler managed to also the seeding to the basic Arweave storage network. Both commits are being picked by our gateway, so we can serve the transaction directly from the bundler, this, let's say, layer 2 storage improvement, but also directly from the Arweave network if someone will decide to go or surpass the bundler service. And all of the transactions could be evaluated using our client, our SDK with the full caching support, or delegated to the decentralized execution network to save on the resources and get a faster answer. And as I mentioned, we currently imagine all of this dance, the execution network, as kind of an application-specific subnets, but obviously it will be great to allow the inter-subnet communication, and also to introduce an incentive mechanism so we can properly guarantee that the state delivered by then is correct. So for that, we are exploring the Cosmos ecosystem as a place to have our base layer for the rollup mechanism. So any then can submit a state commitment to that network in an optimistic way with a validation window. And if no one will challenge that, or if the challenge is properly solved using the bisection algorithm, so the whole network will only need to validate the single differing transactions, then other subnets can import a state from that subnet and use it in their own processing. So the most valid use case for that is that you can create a really fast and affordable in terms of the processing cost subnet, for example, for gaming or for an apps that is issuing, let's say, thousands of NFTs. But whenever you would like to monetize the outcome of that network, like you get a superhero and you try to sell it to some tokens with a significant value, then you can go through this settlement layer, wait a bit for the confirmation, so the state update is being verified and checked by the whole network, and then you can consume the results and receive financially valued tokens. And also it's really crucial at the early stage of the ecosystem to offer developers some tools, because what I talked was a bit abstract, but when someone comes to our environment and would like to try all of the solutions, it's important to offer some libraries, templates, tutorials. Also, we get a publicly available block explorer where you can see and check all of the validity of all of the transactions, the inputs, and also the currently evaluated state, together with a testnet, when you can play on free and do your experiments with the network. And I think it's often overlooked, but having a high quality developers tools really helps for the early adoptions. And talking about adoptions, currently we started to build this product for ourselves to manage the oracles data integrity, but right now we got about 20 projects on Arweave actively using our framework, and there are more and more interesting use cases. I think here we got, for example, Accord that is doing a really cool stuff with the encrypted data storage. We also got another French team, Pianity, that is doing NFTs, and we got a bunch of others. Super interesting projects around NFTs, social media, token exchanges on Arweave utilizing the smart contracts infrastructure. So I encourage you to explore Warp, and if you're looking for a solution that can handle a lot of data, which is not possible in other chains, like data storage, like super interesting NFTs, or you are building your gaming infrastructure project that needs to deal with a lot of information, metadata about what's happening in the game, that could be a really interesting alternative to give it a try. And yeah, we got some developer resources, and we're always happy to talk and also to get the feedback about the infrastructure. We started to work on that a year ago. It's a very small team, and we are very pragmatic on making the solutions really useful to other developers. So thank you, guys.
Do we have questions for Jakub? I had one. What's been the most challenging part of building this product so far?
Sure. So on the implementation side, the actual technical side, like implementing the cross-contract calls from the WASM environment and synchronizing that also with the Arweave, that's pretty heavy engineering. So all of these, like say, modular blockchain structures, they look really great on the paper when you can produce the design, but when you get into the implementation, that's really tricky to synchronize a lot of stuff that's happening around and to maintain the performance while also being able to fully verify all of the transactions.
Thanks. All right. Thanks a lot, Jakub.
Thank you, guys.
Cheers. Nice one. Cool. Should we plug in? Yeah. Beautiful. Okay, guys, please get settled in for our next talk. Nice. Welcome, welcome. Cool. So for our next talk, we have Isaac Sheff, who's senior research scientist at Anoma/Heliax. Today, his talk will explore Typhon, a new software stack to improve the Tendermint consensus and its mempool. Take it away, Isaac.
Thanks. So I'm Isaac. I'm a scientist at Heliax, and I lead the Typhon product group. Specifically, Typhon includes Alex, Tobias, Nakib, and myself in no particular order. Heliax is building Typhon as part of the ANOMA fabric of protocols, which we hope will enrich the Cosmos ecosystem. And right now, ANOMA-based blockchains, the first of which will be Nemada, use Tendermint, which is pretty common for Cosmos. But Tendermint isn't perfect, and we think we can do better. So we're building Typhon to replace Tendermint. And it's going to improve throughput and latency. But the feature I'm most excited about is that it's going to enable a new kind of sidechain, a protocol we call Chimera chains, which support multi-chain atomic commits. So before I dive into that, I'd like to give you a taste of how Typhon will improve Tendermint even in single-chain transactions. To zoom out a little bit, the idea behind most any blockchain is to maintain a replicated state machine. And that machine is replicated across all the validators. It starts in some initial state, and each transition takes it to a new state. Usually individual pieces of state have well-defined permissions on when they're allowed to update, such as only Alice can deduct money from Alice's account. And these are defined in code that has to be checked each time state changes. These checks might be called validity predicates or smart contract transactions or stuff like that. Usually we want our blockchains to be highly available. That does mean that they should be easy to read, pretty much by anyone who has permission to read the state. But it also means that everyone should be able to commit transactions. They should have high throughput. The really tricky part, however, is that we also want to have high integrity. We want everyone to agree on the replicated state machine, even in the presence of failures. And that's what Tendermint does. It provides a basis for maintaining a replicated state machine with high availability and high integrity. Typhon is intended to replace Tendermint, and we're hoping to improve on Tendermint in a few ways. Firstly, Tendermint has a fundamental throughput limitation, and there are a couple of reasons for this. One is serialized execution, which is pretty normal for blockchains, but puts a fundamental limit on the throughput regardless of how good your actual distributed system component is. When I talk about serialized execution, I mean that Tendermint executes each transaction from start to finish sequentially, not just in some equivalent manner, but actually in sequence. This serialized execution doesn't allow for concurrency, putting a fundamental limit on how many transactions can be processed, even if all the distributed stuff were free. Essentially, all applications actually running on the chain itself, at least, are trying to timeshare a single CPU. Ideally, we would want to execute transactions as concurrently as possible while preserving some kind of equivalence to serialized execution, which is what high-performance databases do. We want to preserve an execution that is serializable, which is to say equivalent to a serial execution. Specifically, within any serial transaction, reads and writes should be consistent with the global order of transactions. But when transactions don't actually touch the same parts of state, we should be able to compute them in parallel using multiple machines even for each validator. To do this, we need to break up state into substates. We're thinking about phrasing them as key value pairs, and require that each transaction label the substates that it's reading or writing. Any transaction which tries to read or write state outside of its labels would fail, much like a transaction that runs out of gas. The execution engine could then run multiple transactions concurrently, even on separate machines, updating their separate pieces of state. We're hoping to leverage some existing work in databases to make this run. Specifically, the gold standard database property is called serializability. The idea being that for purposes of reads and writes within a transaction, each transaction observes the world as if it were being executed alone, one at a time, in some kind of serial order. But under the hood, we actually run faster than that, taking advantage of parallelism. This is going to involve an execution engine where validators have multiple execution workers, and mempool consensus engines have to forward the relevant information to them so that they can execute transactions and update the state. The way that Tendermint does leader block proposals also creates a bottleneck that damages throughput and latency. Specifically, at least the authors of Narwhal and Tusk found that a major bottleneck is that each Tendermint block with all of the transactions it contains has to be broadcast by some proposer, some leader, to all the other validators. And this broadcasting can be the limiting factor for throughput and a significant latency problem as well. Ideally, we distribute transactions in a less centralized manner, and consensus would only need to agree on references to collections of transactions that we know are available. Typhon is adapting the Narwhal mempool, published earlier this year at Eurosys, which allows validators to store an arbitrarily large structure of transactions, while consensus only has to periodically order signed references to transactions that are already available. Narwhal lets us decouple the throughput of our blockchain and how many transactions it can add from consensus latency or consensus protocol bandwidth, which is really useful. We do have to tweak it a little bit to allow for Chimera chains, which I'll get to in a minute. And that brings me to, we want to expand Typhon's functionality to handle atomic transactions that update state on multiple instances. This requires changing the definition of what it means to agree on the state machine, since different chains have different validators, and thus different sets of individuals who want to agree. Typhon will enable a new technique, which we call Chimera chains. And to explain where this fits in, I just want to go over a very high level of how Typhon is architected. It's composed of 3 layers, a mempool, a consensus, and an execution, and each layer passes information to the later layers. Our mempool is based on Narwhal to allow, tweaked slightly to allow for Chimera chains. Any mempool on any consensus, on any blockchain has to receive transactions from clients or solvers or whatever you call them, and store those transactions so we know that they're available. Consensus then needs to work with references to batches of transactions, or needs to pass along the transactions themselves. Our consensus layer then establishes a total order of these transactions. Our consensus will be based on heterogeneous Paxos, and we'll try and enable these Chimera chains. And the execution layer then needs to read that total order from consensus and the transactions from the mempool and actually update the state machine with as much concurrency as possible. So at last I could talk about Chimera chains and the cross-chain atomic commit problem. We hope that in the Cosmos ecosystem, many active chains will provide many applications, many of them using the ANOMA architecture, each of which will have their own set of validators, their own security model. ANOMA will use and even extend some existing tools like IBC, which we heard about earlier, to securely send messages from one chain to another. And Tendermint can handle this kind of thing reasonably well. But this kind of asynchronous communication doesn't solve a specific difficulty of multi-blockchain applications. So for concreteness, let's consider the train and hotel problem. Suppose that a hotel tracks rooms using red blockchain, and a train tracks seat bookings using blue blockchain. Now suppose I want to buy a train ticket to Paris, if and only if I can get a hotel room in Paris. I don't want to buy one and then find out that the other is sold out, which has happened to me before. One traditional way to do this would be to use a multi-phase commit. So we'd start with some state. Each chain would commit a transaction saying that it wants to do this multi-phase, multi-chain transaction. So it's locking the relevant state until all the relevant chains are locked, and then no one is allowed to change this state until it's unlocked. So here we're putting a lock on a train seat. I haven't bought it yet, but no one else can buy it while it's locked. And that state stays locked even while more transactions are processed until all the relevant chains have locked all the relevant state. Now I've also locked a hotel room. I haven't booked it, but no one else can book it while it's locked. The other chains will need to receive IBC messages indicating that each of them have indeed locked their relevant state, committing to the multi-chain transaction. And at last, the transaction can take place and the state can be updated and unlocked. So finally here, I have booked the hotel room and the train seat. Fundamentally, multi-phase commits like this have at least 3 problems. And the first is liveness. If the blue chain locks its state and red chain dies, then blue chain's state stays locked, despite the fact that conceptually, the blue state machine should be live. Objects on blue chain, I don't think, should be made unlive because of failures outside of blue chain. And in this example, the train ticket would stay locked and unbookable because of failures that have to do with validators that the hotel trusts, even if the train system doesn't particularly care about those validators. Secondly, and more simply, it takes at least 2 rounds. Every multi-chain transaction requires at least 2 blocks worth of latency without pipelining, because you have to wait for proofs of consensus to receive the IBC messages for the second phase. And finally, whichever chain commits last gets to decide effectively when the transaction happens. And in a market of fluctuating prices and opportunities, that can be valuable. We don't really want to incentivize chains to delay anything. So Typhon introduces a new solution to the atomic multi-chain commit problem that I call Chimera chains. So suppose that we want to atomically commit some transactions to red chain and blue chain. We propose that what red chain and blue chain instances need is a third chain, a place where in the train and hotel example, both the train ticket and the hotel room can be booked atomically. And we call this a Chimera chain. Most importantly, red transactions on the Chimera chain get all the same guarantees they get on red chain. They won't lose safety or get stuck because of something that wouldn't stop red chain. Likewise, blue transactions get all the same guarantees that they would get on blue chain. But crucially, this chain supports batches of multi-chain, in this case some red and some blue, transactions that will be committed atomically. Either everything in the batch happens or none of them will, within a certain guarantee. For example, we might want an atomic batch that includes a red transaction booking the hotel room and a blue transaction booking the train ticket. Either both get booked or neither. And we're going to do this using a consensus protocol based on heterogeneous Paxos, which I published at Opus in 2020. Heterogeneous Paxos isn't magic, but it gives us a specific failure tolerance under which we get this atomicity guarantee. In a sense, a Chimera chain is a bit like a trusted bridge. You can run transactions on it, and you'll get this atomicity under certain trust assumptions. And these trust assumptions arise naturally from the quorums of validators on each chain. The more validators they have in common, the stronger the atomicity guarantee. In practice, proof-of-stake chains often share a lot of validators. There are something like 30 companies that run validators professionally, so we expect a lot of ANOMA instances will be able to have quite secure Chimera chains between them. But this does naturally raise the question, what does it mean for the base chains to be safe if we lose atomicity? Well, it means that in some sense the Chimera chain has forked. But here's the useful property that we get from heterogeneous Paxos. So long as red chain's consensus itself remains consistent, red chain perceives a consistent Chimera chain. In some sense, for red chain, the Chimera chain is like an ordering shard or an additional side chain. Blue chain also remains consistent. Blue nodes perceive a consistent Chimera chain. Without atomicity, red's Chimera chain might get incorrect information about blue transactions. It may think that a hotel room was sold out when it was in fact available. The atomicity guarantee is simply that the Chimera chains that they decide on will be the same. Then, of course, there's the Chimera state machine itself. This requires some work in the execution layer. I mean, the API that we're using to represent the abstraction barrier between consensus and execution is called IBC-I++ for Abstract Blockchain Interface ++. So let's assume that the chains involved here have their own state machines, each written with, to communicate with their own ordering mechanisms via IBC-I++. Then one of the remaining challenges is that for our Chimera chain, we need to write our own state machine, which runs these atomic multi-chain transactions. And the easiest way to do this would be within the Chimera state machine to run instances of the constituent state machines. And we know how to do that. We can communicate with these instances via IBC-I++. Now the transactions for our Chimera state machine will be bundles of transactions spanning each of the constituent state machines. So far, we can keep everything in IBC-I++ abstractions. If our chain schedules an atomic bundle of transactions, our Chimera chain schedules the transactions from the bundle for each of the constituent state machines. But a lot of these transactions probably want to include computation based on the current state of the state machine. We will want to add some additional communication interface whereby transactions running on the constituent substate machines can send information to each other or even get replies within the same bundle. You could imagine writing code on the hotel side that sends some kind of a message to the train side to ask which seats are available and gets a response back and makes decisions accordingly. That means adding yet another communication interface, this time not any literal communication over the wire, but rather taking place entirely within the Chimera state machine. But it's going to require some support from the constituent machines and their transaction languages. So hopefully that gives you a taste of the Chimera chain project. They are a general way to atomically commit transactions across multiple ANOMA instances without multiple rounds of locking resources, hopefully making things as fast as they theoretically can be, at least in the easy case. We hope that with better multi-chain support, people won't be quite so incentivized to force all their applications onto a single chain. And having many interoperable instances reduces congestion and costs, but it also allows each application to choose a trust model that's actually right for them. Chimera chains will be a key feature of Typhon-based ANOMA chains. And the core component that enables them is our heterogeneous Paxos-based consensus layer. I just want to talk a little bit about where we spent some of our time recently working on Typhon. And that is formal verification, specifically for the mempool and consensus layers, at least so far. We've been developing formal models for our mempool and consensus in Leslie Lamport's TLA plus specification language, and then building formally verifiable proofs for those models in the TLA plus proof system, which was created by Lamport with folks from INRIA. Specifically, we're able to prove key safety properties about heterogeneous Paxos, and we're working on proving our mempool ensures key availability properties. We're also able, in these specs, to model check at least small hypothetical setups, which has already allowed us to check some liveness properties, even if they're harder to formally prove. This has actually helped us uncover and fix a subtle bug in our original heterogeneous Paxos spec and update it accordingly. We think that this kind of work is really important given how subtle bugs in Byzantine systems can actually go undetected for an extremely long time. So we want to make sure that we get ours correct. So that's Typhon. It's a replacement for Tendermint. It's built with a narwhal-based mempool designed to fix the block proposal bottleneck, a heterogeneous Paxos-based consensus protocol that facilitates Chimera chains and addresses cross-chain atomic transactions, and a highly concurrent execution engine that preserves serializability without the serialized execution bottleneck. The ANOMA framework will allow people to build Cosmos blockchains using Typhon and enable Chimera chains. You can check out the English language spec in progress here, but we're hoping to have a full spec proposal coming soon that may end up going through peer review someplace, maybe Financial Crypto or Eurosys or something. You can also check out progress in the formal specs and prototypes on GitHub. And finally, we are hiring. Especially if you are an expert in concurrent serializable execution environments, contact me. Are there any questions? All right, I have confused everyone.
This is cool. There's like another effort to integrate. There's another effort at Similia to integrate Narwhal with Tendermint, which I should get you in the chat.
I would appreciate that.
Yeah. This is definitely like matches my mental model of like where consensus should be going. So this is very cool.
Thanks.
I got a question. It's regarding about locking assets. Maybe if we can take the example of the train. Let's say that, how can I say? A malicious actor just want to lock it, but for, I don't know, an unlimited time during. How do you manage that? Because if someone else want to take a ticket for the train, it will not be possible to do this.
Right. So that is a problem with multi-chain atomic commit-based systems, and there are several ways that people have chosen to address this. So in particular with Chimera chains, we don't have to lock the assets. We can move them to the Chimera chain where they have the same liveness properties. The atomic bundle will buy the ticket or not. If it doesn't get committed, then someone else can buy the ticket. In other atomic swap setups based on multiple phases, there are often protocols involving timeouts or some kind of deposit that incentivizes people to not screw it up. But I'm not an expert in this.
Okay, thank you.
Cool. Thanks very much, Isaac.
Thank you.
Yeah, I don't know what the map is. I'm so busy. I cannot come to all of you. I wanted to come to all of you. He wants to do this, right? So I was like, I don't know, I was like juggling. I spoke with Flash Pods and
No, I don't know. Are you a television? Yes.
Hey everyone, so up next we have a panel on regulation. I just have to find our panelists, so or Zaki can give us his own keynote on regulation. But yeah, we'll take just a couple of minutes for me to bring them over. They're probably just down there, and then we'll get started. Thanks for your patience. Sure. An important update on coffee. Coffee in the restaurant downstairs is you have to pay for it. If you want free coffee, you have to go to upstairs to the rooftop.
Hey, Zaki.
Hi, Zaki. Nice to meet you, Simon.
So many
Yep, among other things. I also pretty much built the protocol that this conference is for.
Okay.
Like this whole thing. I ran the organization, launched the thing, told people to build on top of it, convinced all of these people that they should build their lives around it.
Okay, and then you decided to
No, I work on like 20 protocols.
Okay. Very cool.
Mec plus stratégique. C'est un peu tricky. Ça a l'air de marcher.
I can sit there.
In the throne.
Yeah, yeah.
You want to sit in this one?
Which one do you want? Okay.
Je mets ta gauche ou...
Non mais vas-y, mets-toi là, je vais mettre là.
So please take a mic. Remember to speak close to the mic.
Thank you.
Sure.
Là, regardez.
Oh.
Ouais. Oh, je vais maintenant.
Okay, thanks everyone for your patience. So our panelists are now here. We're going to start. This is a panel on regulation that is moderated by Charlie Perreau, who leads startup coverage at Les Echos, which is a big French newspaper. So up to you, Charlie. Take it away.
Hi, thank you. Hi, everybody. Thanks for being here. So the topic of this roundtable is, are we on the cusp of crippling regulation? So with me on this panel, I have Faustine Fleuret. You're the president of ADAN, a non-profit gathering a crypto ecosystem in France. Simon Polrot, you're the head of EU Crypto Initiative, which is also a non-profit. Then we have Zaki Manian, you're co-founder of Sommelier Protocol. And finally, Xavier Lavayssiere, you're an independent researcher. So we're going to start by a big news, we're going to say that, about Russia, because I guess you saw that a few days ago, Russia just banned crypto payments. Do you think this measure will spread all over the world, or do you think this will remain just an exception? So are you worried about it or not? Simon.
Thank you. Hello, everyone. So, very quick. So the payment functionality of crypto has always been something that the regulators are more afraid of compared to the other, like investing or even using it as DeFi or anything else, because the payments rails are really used by everyone in the day-to-day activities, and they are heavily surveilled, heavily under surveillance today by a lot of intermediaries. So cutting off all these intermediaries and basically allowing all the citizens to be completely off the financial system, it's probably something that is more worrisome for the regulators if they are seeing as crypto as a risk. So it really makes sense that, as an example, in Russia, you ban payments, but you don't ban investment, because investment is not seen as a threat, whereas payments without control is seen as a threat, potentially. So it could expand in other countries that really want to keep a tight control on the payment flows of their citizens, because, of course, crypto allows to circumvent that in some ways. Could allow, because today it's not really used as payment, as you know, but it could happen. But it's probably something that should remain really for the countries that really have this tendency of maybe overreaching control on their own citizens.
Faustine, do you agree?
Yeah, sure, and that's what we noticed in the EU debates to build a regulation for stablecoins. There were stricter and stricter rules on payment stablecoin with time. So now you have limits on the issuance of payment stablecoins that were introduced. You have a stricter supervision too. So yeah, it's not a ban, but the regulators and the European institutions really wanted to take care of the development of such stablecoin, payment stablecoin, and the reasons behind were monetary sovereignty and stability too.
If you want to add something, what of you?
Yes, maybe the difficulty is that you have to balance all the different components of what your money is, right? You want to. We are at the stage where most payment rails are being challenged in a sense. You have the potential introduction of new central bank digital currencies. You have the ideas that there are many startups that are starting to offer payment services. You have all the big tech that are also entering the payment space. So we are at the stage where the regulators, it's not just about crypto in a sense. So it's not a question to be offended. It's a question about the payment rails are shifting quickly and mostly driven by the private sectors, and states have to figure out what makes sense. And some of the worries are legitimate. You mentioned the surveillance aspect and the sovereignty, but there is the dollarization, so the fact that a lot of countries, and especially developing countries, get dollar way too easy in their economy, and that weakens their own currency. So I'm not an economist enough to know what are the trade-offs here, but definitely there are different challenges.
How much of this do you think is just a backlash to Libra, right? Because crypto isn't used for payments really, and it's not really clear that it ever will be, at least consumer payment rails. But there did seem to be this thing where a big tech company was trying to use sort of crypto as a backdoor to set up an alternate payment rail system that was independent of governments. And it does seem like most of this has nothing to do with crypto and everything to do with we saw that Facebook almost found a little backdoor through our system, and we had to close that backdoor.
I definitely agree that Libra has been the sparkling element that triggered countries, because when you say we're going to launch a global currency, I think you just chose all the right words to trigger the people that are in charge of currencies, of global affairs. And
what I told them is the only thing they could have said that was scarier is if they'd said they'd raised a standing army.
That could be a point. But I don't fully agree with what was said before about the fact that crypto is not used for payments. It's not used for payments as we are used to it in shops and so on. But what we are starting to see with DeFi and so on is gaming, where you can have this money and so on. And the digital world is so important that slowly having the native payment to the digital world, it starts to be relevant. Probably they don't measure it even, because I think it's even stronger already than they expect.
Yes, that's a big point. How do you measure the payment activities of a stablecoin or of a crypto? Because on the blockchain, a payment on investment transaction looks the same. So it's you can put into law, but then how do you enforce anything that would ban a payment transaction? It's an open question.
Simon and Faustine, you're in contact with a lot of European regulators today. Are there different levels of understanding regarding crypto? Did they understand, just Bitcoin, Ethereum, and then DeFi, NFT, it's another thing?
Yes, and actually it depends also regarding member states if they had already engaged into some regulatory work before. We were talking about the harmonization of EU regulation. So yeah, even if France was a precursor, if we take each country, when they started to look at how to regulate crypto, of course they heard about Bitcoin, and sometimes that's the only crypto that they heard about. And then actually we had to educate them to other things, and that's why at the beginning, when there was the MiCA proposal by the European Commission, and that there were kind of a prohibition of DeFi, we asked if it was the purpose to prohibit DeFi, but actually it's just that they didn't know about the existence of decentralized finance. So they created rules that were completely inappropriate. And what we see now with, for example, NFTs is that, yeah, they hear about NFTs in the news. There are huge news for months now. But they assimilate all of them as an homogeneous asset class. And yeah, we have to, because there is still a poor education about crypto assets, explain and re-explain because they really want to go fast on regulation and do not really take time enough to better know about the whole crypto ecosystem.
Yes, and just to add quickly on that, the most dangerous confusion is, of course, between the CeFi and the DeFi actors. It's very difficult, also even for us, like to create legal definitions of what really is a decentralized protocol and a centralized one, right? And there's a spectrum of decentralization. So you want to avoid a regulation that allows anyone to say, okay, I'm DeFi, so I'm out of the regulation, because that would be a bit too easy. But at the same time, everything that happened around Celsius and 3 Arrows Capital and everything, you hear a lot of high-end officials of different institutions saying that it's a failure of DeFi, which shows a complete lack of a basic understanding of how the market is structured and what DeFi really means, which is completely entertained by the centralized actors that often pose as DeFi actor or CDeFi actors. So the confusion is really complete. I think this is the most significant threat that we have now, because this confusion brings also a lot of uncertainties on the future of DeFi, and we may fear that the regulator puts everything in the same basket and the same analysis for everyone.
Maybe, Xavier, do you think the regulators are objective? You have 3 hours.
So there are different dynamics between regulators, right? Like there is the objective of like making the market work well. There is the objective of protecting themselves to not be exposed to too many litigation later on. So, and of course there are different lobbying groups also that pushes in different direction, but crypto is also part of it. The thing I want to highlight is, especially when you mention like DeFi, CeFi, we are using really technical definition that everyone that has taken the time to fully understand how it works is comfortable with, because DeFi is really, it's not so much decentralization, but really the fact that you are leveraging some technologies and a certain way of doing things. And regulators are not used to think this way, because they think in terms of large categories. You mentioned like categories of assets and so on. And all of a sudden, all the distinctions have to be made through technologies. One example I have in mind also is wallets. I feel like a wallet, we have an intuitive vision of what it is. In crypto, there is a specific definition, something that holds your keys and allows you to interact. But then for regulators, they see that when you have an account on an exchange, what is it exactly? You own crypto, but it's not really a wallet in the end. And they have called that in the latest regulation as a hosted wallet, which has lose absolutely the meaning from the technical vision. So just to say that we have concepts that are quite fairly technical, and it's really hard, and it's not the culture of most people working on this aspect, on legal aspect and regulation, to understand those details in the end, but that are not details, that are what define everything that happened after. So that's the challenge for them.
Do you want to add something to that?
Okay. I think it mostly, like, these are the worst thing, like, you know, the part of the problem, like, okay, so like things that the crypto industry is bad at. Like wallets are a terrible name for everything. And do a really bad job of communicating like what functionality and everything. And it's very connected to like the way like Bitcoin worked, rather than like generally how like, especially like more modern crypto platforms work. And I completely agree that like this like fuzziness that has been exploited between like CeFi and DeFi is like the biggest threat to the industry. Mm-hmm. And like honestly, I'm like very happy that like the Celsiuses and all have like died in this like latest cycle before they got like much bigger.
Mm-hmm. Of course, we're going to talk a little bit about Mika. Do you think it's already outdated and we have to think about Mika 2?
Actually, they are already thinking about Mika 2. But that's a good news because actually in Mika they decided, and we were a lot of to push for it, they decided not to deal with some issues like DeFi, like NFTs, because it was too early. And of course they were also on news like Celsius, etc. So we could fear that they wanted to cover lots of things in this Mika first, and finally they don't. But what we know is that even if we had some political deals in June, so we have the political vision of what will be the EU regulation, we also know that, okay, they won't deal with DeFi, with NFTs right now, but the European Commission and the European regulators will start to think about this right now, to think about what could be a different paradigm for DeFi. How could we build maybe a bespoke regime for NFTs? Do we need deeper environmental obligations for Cusp or fears of crypto assets? So we have a political vision that is clear in the short term on this Mika, but we also know that they will work a lot for this Mika too, and that it will start really, really soon, and that the industry needs to be involved. And that's very important because sometimes the inappropriate and unadapted rules that were decided on, in Mika, because they were good news but also bad news, it's because they don't know the industry enough, and they don't speak to the crypto companies enough, and they don't assess the impact of the rules that they are decided in the debates that they have in the parliament, in their working party. That's what they call. So we do need that for this further Mika round. We are all really involved, and we are constructive with the regulators, meaning we need to explain them, to accompany their work, and give them enough information to make a regulation adapted and appropriate, because there will be regulation. I mean, DeFi won't remain unregulated, NFTs too. So we really need to be there in those debates.
Simon, are you already planning for the next phase?
Yes. So there's already a few initiatives in place, actually. The Commission is preparing a report on DeFi and will probably open a consultation at the end of the year. They also want to work on NFTs specifically. There's the pressure of different international institutions to rush a bit on Mika too, and cover everything. There's other organizations like FATF that are probably discussing around DeFi and NFTs also now. So everything, I would say that every single institution, financial institution today is thinking and talking about crypto. So yes, we are on the verge of new regulations. The question is, will those regulations be crippling? And at the EU level, we have mixed signals because it depends on the institutions, but generally we've had a lot of constructive discussions. So we hope that the industry will be sufficiently large and mature at the time where the discussions will actually move forward, notably with regards to DeFi, so that we can have a real impact on the text and basically make it so that the DeFi regulation does not cripple DeFi, notably in Europe. But that's still an open question.
Yeah, on this, I think this thing that's the most infuriating to me is the fact that you have people that try to make good regulation, like good students, like they apply some principles and we are sure that everyone is going to be safe, but there is no strategic thinking about that. And especially, I'm probably a bit pro-European. I don't see a thing only in a global objective way. It's like it's terrifying to see that nobody in the discussion, and as you say, like nobody really measures the impact of the regulation. They are just trying to make sure it's good, the way it's defined abstractly. But what are exactly the policy objective in the end? What we want really to avoid, and it's not really clear in the end. We want to protect consumer, but what type of consumer? What threat are really terrible? What we want to avoid? And so in the end, you have a lack of strategic thinking around the regulation. I don't think that regulation should be just making rules based on vague principles. It's a policy action. As a society, we want something to shape, and we do for that. So there should be more, probably it should be at the political level. There should be more political debate about it, trying to have a vision of what we want to achieve, and then make the relation out of that. And at the moment, it's really like a student exercise of making something that looks neat but not really strategic.
But I'm not sure that the mandate of legislators and regulators is competitiveness or development of innovation, and that's the point actually. The goal of regulations are investor protection, the smooth functioning of markets, the fight against financial crime, etc., etc. But there is no intention to help to build the competitiveness thanks to regulation. And actually that's maybe the very different approach that we have in Europe, and that in the US they have a completely different approach, and that maybe they go a little bit less fast than us regarding regulation, but because they have maybe a more clear ambition that they need to develop this innovation, and that's something that is missing in Europe.
And the terrible thing is, I feel like then we throw public money at innovation, and especially at the European level, we finance research. And there are crypto projects that have been funded by public funding in the end. Especially in France, we have like really good research centers that have been well funded, that have contributed to protocols. So, like for instance, CEA and so on. But then, when it comes to get the money back and get the ecosystem, there is no the full reasoning on how we really have innovation, which to me is not only a question of technology, but then having the companies and so on.
But are all the regulations that are existing now really helping the crypto industry? I mean, in France, everybody knows we have the PSAN, but there are still a lot of issues. Everybody is like, oh, I have the PSAN, but they can't even open a bank account. So, is it really helping at the end?
The fact that we have a regulation in France for 3 years now, there is a mixed feeling about this because there were new rules, and it was required for the structuration of the industry. There were also the intention to help on some issues that existed. You were talking about bancarization, and that's the point where the regulation was not a solution, and that it's still very difficult for French companies, for French crypto asset service provider to open a bank account in a French institution. You also have other issues that emerge actually, because we are talking a lot about regulation, but we less talk about supervision. That's the point. If we have rules, we need someone to check that rules are applied. And we have now, I think, 45 providers that are registered with the French regulator, but you have many that are not, and they should be registered. But we see nothing from the supervisor to push those other companies to register. And actually, at the end, it means that those who played the game of regulation, the fair people, they are not rewarded for that. And in France, the problem is that we have a regulation that is before others. It doesn't help, for example, to passport in Europe. It doesn't help to expand the activities. It's really, we reach the objective of fighting against financial crime, but we have this loophole because they need to go to other banking institutions. We know that French institutions are really credible regarding financial crime, but if you push Cusp to go to other institutions that are less serious about that, we don't reach our goal to fight against financial crime. And if you leave some entities that do not comply with this regulation, if they are not sanctioned, if you don't push them to regulation, we also miss this objective. So we really hope that with the EU regulation, at least for those registered Cusp, well, this harmonization will help for the passporting, for structuring the whole EU ecosystem, and that there is a better level playing field that actually doesn't exist today.
Yeah, unfortunately, the regulation cannot change the stance of banks against crypto, and there are private actors that can decide, even if they are a critical infrastructure, in the end they are still private actors, and they can decide who they want to work with, and we have not been able to find like a practical solution to actually force them or convince them. I don't know, because it's really the situation has not really improved with banks. They are seeing crypto more and more as a threat, and not really as well, with exceptions. But there's been like changes of mind where banks were quite open, and now they are even more hostile. So that's not a good sign.
Zaki, do you have any difficulties right now? And are you ready, to play by the rules, as Faustine said?
I think it's what's frankly interesting about the like EU experience versus the US experience is in the US basically there are no rules in the sense that no one knows what the rules are. We have this like defined rules through court, like through settlements, right? Like enforcement red, which actually makes it like sort of, to some extent in the EU approach, there are at least some semblance of rules, and you can like sort of figure out like what jurisdictions you want to operate in and like what risks you're exposed to. Whereas in the US, it's literally like no one knows the answer to this question. Like you can spend millions and millions and millions of dollars on legal, and you'll just be like, okay, like here's a bunch of theoretical stuff that might be useful someday, but there are no rules. Right, the rules are whatever the lawyers end up negotiating, or in the event that something goes to court, whatever judges decide, which is like practically more hostile to for a lot of protocols than the EU is.
Yeah, we've seen that a few days ago with the SEC lawsuit against Coinbase that named 9 assets as securities, and that's one of the first time where they do that, and it's coming out of the blue, and now we have those 9 assets. Why those 9 assets and not the 20 other ones that were also traded by the same guy that is litigated against? So there's no legal clarity really in the US. That's probably something that the EU has, that now with MiCA will have very soon, that the US doesn't have. But what we see is that in practice, it's still easier to. There's still a bigger market and a more dynamic environment to create business in the US, despite this. So maybe the regulation is not the only factor here.
I mean, the practical structure actually is for most crypto entities have to be multi-jurisdictional. Yeah. Like that's the only actual way to like put all the pieces together that you could need to operate a business. Is you need to have like if you look at most like crypto things, they have like a US entity, a European entity, a BVI entity, a Caymans entity. Like we've strung all these things together, and somehow we're able to like craft through like routing like different activities through different jurisdictions, like something that seems like a coherent structure.
But probably there's something I think interesting of crypto, and that might help to change other things. Is natively crypto is global, by default it's global, and then the regulation artificially is something you have to cope with in a sense. And probably it's not the case to many other businesses where usually you start in a country and you start expanding your operation. Here your operations are global from day one, and then you might have to deal with some...
Yep.
Xavier, do you think there are other things to regulate, other players to regulate yet? Can you be the bad guy?
No, what we see and we discuss here is the problem that all those decisions are making on the existing ecosystem. But at the same time, there is also, we have to address the problem that on crypto at the moment, there is a lot of scam. There has been different waves of people losing their money in different forms, like pure scams on one side. There's been projects that have been kind of legitimate, but have lost a lot of people. And also the hype about crypto, like it creates these bubbles of excitement, those TikTok videos where people build on top of like they lack knowledge, and then they become influencers. So I'm not sure who's coming who, because like you have several levels of an understanding. But the question here is, so first, when we are trying to define the line on subtle projects, probably is to be harsher also on everything that's really bad. And so we have seen some CeFi actors that were doing things that are obviously absurd, and it's probably a lack of regulators to be able to identify things that are obviously, and before going about DeFi, I'm certainly pissed about all the reports about DeFi at the moment, when we have obvious scams at the moment in the crypto ecosystem that you don't need to look at DeFi, you just look at things that are obvious crimes and deal with that first, right? But the difficult part is the second layer, which is all this ecosystem of influence, the link with social media, the Discord channel, and probably there's something new that also is like there is no enough thinking about that yet, because the same problem we had with fake news over the past years, but it's like there is a full digital ecosystem of information that probably is part of this problem, and we need to have a reasoning on it, and I haven't seen yet any sort of starting of logic of how that could be a bit domesticated.
Nice, thank you. And maybe to finish, we mentioned, of course, the European regulations regarding crypto, but are there other types of regulation that can affect crypto besides what we said?
Actually, the two texts that are the most advanced right now are MiCA and the transfer of funds regulation, but that's not the end of regulation for markets in crypto assets. You have actually a package for AML, CFT, anti-money laundering and financing of terrorism that is built on 4 texts, and they will all concern the markets in crypto assets. So TFR, there was a political deal. That's where we are the most advanced. But there will be a lot of debates in the coming months and years on if we need to a European supervision of market in crypto assets in terms of AML, CFT, and all the other rules that they will need to comply with. There will be other topics than AML, CFT. You will have prudential requirements also that will be developed, and you have currently a consultation by the Basel Committee on what could be the prudential treatment of markets in crypto assets. We talk about the topics that will be studied for MiCA 2. So it's only the beginning, and that's why my main message is that the industry must be ready to be part of those debates and to help to build those rules so they are the most adapted and the most proportionate. And we are all only talking about Europe because in the US, in the UK, in Asia, we are at very different stages of regulation, but they will look at what we are doing in the EU, maybe to do something more attractive, more adapted. And so that's why we have to work on this, okay, but we also have to take care that we do something where we will still be competitive in the international stage, and that's why it's a problem if in the mandate of regulators we don't have competitiveness, development of innovation at the end. So we need to be in these debates, really.
Okay. And last question, do you think we're going to finish by an optimistic touch, of course? So yeah, are you optimistic for in terms of regulation? Do you think it will not stop people from innovating?
So maybe a first stab at this. What I'm optimistic anyway, I think it's been acknowledged the value of this ecosystem, and it's kind of it's done. It's like until 3 years ago, it was not obvious that all of this would end up in a terrible like crackdown and everyone going to jail or something. I think that now you have seen enough views, and there is now enough understanding that there is value in this ecosystem, in what's and this way of moving assets. Globally with a lot of guarantees, the ability to compose different systems, the open source, so all of this I think is kind of acquired, and so whatever happens, and then there's going to be a lot of rocky road, and we're going to have work to do for the next decade. But the underlying objective of all this ecosystem, I think, is not difficult to be. Really stop. Like there is now a shared view globally that there is an interesting thing here happening. So yeah, I'm optimistic on that.
Zaki?
All I would say is it could have been worse, as he said, and so that makes me optimistic.
Yes, I agree. Basically, with EU regulation, it's fine. It could have been worse, and I feel like we are. You're right. We are quite past the time where the regulators were still pondering, should we ban it? It's not happening. In developed, in Occidental countries, in the US, in Europe, it will not be banned. So this fight is won. This is already this is already a thing. But then after that, of course, there's all these things that we are developing around crypto that are each a different fight. So it's only the beginning. But yeah, quite optimistic in the end because quite also certain of the core values that we have and the core value proposal that we have. So.
Faustine, would you like to conclude?
On a positive, that sure, Mika could have banned DeFi, could have put NFTs as crypto assets. I think we avoided really bad ideas. So we must be happy about that, and that's because the industry was involved in that. Because EUCI, ADAN could be the interlocutor of those European institutions, because actually it's normal that they are not crypto experts. I mean, legislators, regulators, they are covering many topics, and we don't expect that they are crypto experts, but we expect that they hear, they listen to the voice of the industry to understand the impact of this regulation. What would be the best rules to reach those objectives that we actually all want to reach? I mean, we are all agree that we need to fight against financing of terrorism. We need the investor protection. I mean, we all agree on that. So industry and regulators do need to be involved. The industry needs to be involved with the regulators to bring the knowledge that they don't have, and regulators must listen to the industry to build a regulation that is really useful to everyone, actually.
Well, thank you. For that. If you have one or two questions, it's time. We have 2 minutes or 3.
So a couple of you mentioned that one of the biggest dangers to DeFi and in the regulation sense is being confused with CeFi. But if DeFi at least can do, when it comes to malicious things, most things that CeFi can, are there reasons that CeFi should be restricted by more regulations than DeFi?
I don't think it's about more regulation. I mean, it's just that we can't apply the same regulation on DeFi and on CeFi. On CeFi, you have intermediaries, then you can apply rules to intermediaries. That's why MiCA was the proper regulation for that. But you can't apply the same rules to DeFi, even if you want to reach the same goals, because it will make no sense, and actually they would just be non-compliant by default if you do like this. And that's why we called for the proper regulation for DeFi in due time, because I think regulator thinks that DeFi is huge and systemic, and actually it's not. So we have time to think about the good paradigm, regulatory paradigm for DeFi that needs to be different than for CeFi.
The only other thing I would say is that protocols can do many of the same things as intermediaries can do, but the way you regulate protocols and the way you regulate intermediaries have to be completely different. And we're not even really at the stage where like anyone and any regulator anywhere in the world has even like thought about how to regulate a protocol.
Yeah, it all stems down to the control, right? Because if you regulate a centralized entity, then you can apply to them a lot of obligations with regards to the client's funds, with regards to guarantees to make sure that you are not going away with the money. Those kind of things you can implement them with as smart contracts are obligations inside of the protocols. So it doesn't really make sense to apply per se exactly the same thing, and it's not even feasible for the protocols to apply those rules.
But is that a question of just we don't know how to apply these rules that we think should be universal to DeFi, so DeFi should be able to do whatever it wants? Or is that a question of protocols should be allowed to do this, but for some reason intermediaries should not be allowed to do this?
What I think is DeFi has very different risk profile than CeFi. You have no risk of losing the funds of the users because the funds are in the protocol, but you have really strong technology risks, so you need to audit the smart contract and so on, and the best practices in the space are probably not enough, as we see too many hacks and so on. Then you have a lot of risk, and like for instance, you have the complexity of using it, you have the asymmetry of information of users and so on. So it's totally different than CeFi, where it's really a question of a contractual relationship between an entity and a person, and then everything is about regulating that relationship. That's also a bit asymmetric, but differently. And so there needs to be a well thought process, adapted regulation for DeFi, but the base part is to say it's a different risk profile. You don't risk to do the same thing, so you need to redefine the way you apply. So it can be the same rules, but the objectives, then we go back to well define what are the policy objectives in the end, what we really want to make sure that society, how society work, that we need to define to be able to adapt.
I'm not sure there are CeFi risks that aren't DeFi risks. I can build you a decentralized protocol that lies to people and steals their money.
Sure, but you will do it differently than you would do with CeFi. You will
at a legal level.
Yes, of course. You're not operating the same way, so the risks are not the same.
One last question, maybe? No? Okay, well then we can wrap up. Thanks so much, guys.
Thank you.
Yes. And for some reason it's the next. Can we get the slides up, please? Thanks. Cool. Everyone, please get settled in for our next talk. Take your seats. Welcome. Not quite settled in. Guys, would you mind please getting settled in for the talk? Thank you so much. So up next we have 0x Brainjar, founder and CEO of Composable, who is going to talk to us about IBC-Enabled Parachains.
Hello. So obviously excited to be talking today about all the work we're doing, but I think it's also really, really important to just take a look at this slide for a second and ask ourselves, did we ever expect something like this was going to happen? Because I think in the not so distant future, Polkadot and Cosmos were very much at odds, and we're sort of bringing these two ecosystems together by bringing IBC to the Polkadot ecosystem, but also utilizing CosmWasm as a framework for XCVM. So I think the biggest problem in crypto has just generally been how can we actually build applications that make sense from the user perspective, where you have this kind of agnosticism, but also simplicity from a user experience perspective. And also I think we've now reached the point in crypto where efficiencies of the markets themselves are destined, because of this kind of extreme fragmentation we've seen across all the individual markets across the DeFi space. This now invites the same sort of parallels between the equities market and the electronification there, where you saw DTCC serving a huge role in sort of merging all these markets and then resulting in more sort of user-facing applications like Robinhood, et cetera, once this efficiency had finally been manifested. And so what we've built with XCVM is a cross-chain virtual machine that serves as a orchestration layer for interoperability protocols, primarily focused on IBC, but other transport protocols can also be utilized to build aggregation protocols, retail-facing applications, and really making sure that users just have to focus on what they'd like to do as opposed to how they'd like to actually accomplish that. So when we set out to actually build retail-facing and sort of kind of mass adoption type products, we first looked at the broad interoperability stack. So initially looking at IBC, Nomad, etc., and quickly realized that there needed to be an orchestration layer. If you build something in the EVM context and you use something like layer 0, you're still stitching contract to contract in a very much kind of A to B to C process. There's no way for you to actually put together higher order logic for more complex applications. For instance, if you want to open up a position on a derivatives protocol, hedge it out, and also take out a loan on another chain and then invest that loan into an AMM to yield farm elsewhere, there is no sort of stack available to be able to write all these instructions in a single contract and then make sure that execution actually was happening. And so we then decided to build XCVM, which is essentially a smart contract framework on top of CosmWasm that allows for a single contract to have all this logic associated with cross-chain orchestration and be able to pass messages from chain to chain to allow for this full instruction set to be executed in a timely fashion. What this then sort of introduces is this concept of building natively cross-chain applications. So now for the first time, users and developers can interact with a framework that lets them be able to allow for this kind of high-level logic associated with interacting with multiple different chains, all from a single contract, all deployed onto a single chain. So how do we accomplish this? What is the technical stack? So I think most of you have probably already heard about what we're doing based on the work we're doing by extending IBC to other ecosystems. So for the first time, IBC is leaving the Cosmos ecosystem and going to the Polkadot ecosystem. We are the team that's spearheading that. We're also expanding IBC to near as well. And so we're sort of going all in on IBC as the desired transport layer to fuel XCVM. And then additionally, we really like WASM as a smart contracting framework for cross-chain applications. And so we've actually ported CosmWasm, taken out the sort of Tendermint-specific host functions, and have deployed them onto our Parachain, have deployed CosmWasm onto our Parachain as a palette, essentially a CosmWasm VM. So speaking a little bit more about why we decided to do some of these things, I think CosmWasm was kind of obvious. There really wasn't an alternative framework that made sense for cross-chain smart contracting for our use case. But obviously there's a whole bunch of different bridging solutions out there, but we found that IBC is essentially the most trustless solution out there and also the most extendable solution. Where we come from in Polkadot, everyone talks about XCM, and actually XCM is not extendable to other ecosystems at this time. And so for us, choosing the most trustless solution to go all in on and push our development forward, we decided to really go all in on IBC. So why does trustless bridging even really matter? I think it's pretty straightforward. Obviously, we've seen many different bridge hacks, etc. But I think also you cannot build cross-chain applications or user-facing applications that tap into multiple chains and expect this whole thing to work if you don't have a solid foundation, aka trustless bridging. And so for us, it was super important before we could even start contemplating what is the architecture of XCVM to actually really push forth trustless bridging and build this foundation, because otherwise there's no way that an instruction set that's passing from between 6 different chains could be executed, and you'd have to rely on essentially trusted validator bridges, etc. So for us, this has been like a sort of core foundational concept with which the rest of our sort of products sort of expand out of from this central core foundation. So speaking a little bit more about expanding IBC, I think the reason why bringing IBC to other ecosystems is complicated is because of the fact that those protocols need to change in various specific ways, adding various host functions, etc. So it does require a fundamental change in the actual protocol itself, but we've taken a lot of steps with the Polkadot and Near ecosystem, speaking with the core dev teams to really push forward IBC to these ecosystems, but it's obviously difficult. And so we started this work about 9 months ago, and we're excited for Q3, Q4, where we can start to see some of these examples and actually start having DOT and Cosmos assets being able to be moved between both ecosystems. And then the Near initiatives we started, which originated a few months ago, our lead developer, Blas, is now focused on discussing how to adapt the Near protocol to make it more extendable for IBC. So this is kind of how I imagine XCVM in a sort of picture form. So obviously, composable, just like in the Cosmos ecosystem with Cosmos SDK modules, we have palettes in the substrate context. So we've built several different palettes within our Parachain runtime to allow for execution for things like our DEX, our vaults, and of course our CosmWasm VM. And so the intention here is for XCVM to basically become this higher level orchestration stack that not only taps into this infrastructure, but also by tapping into this infrastructure is able to extend these messages and communication orchestration outside of the composable ecosystem. So from a developer perspective, this really isn't that much different than just writing a CosmWasm contract. What's nice about CosmWasm is it was built with IBC in mind. So being able to create a contract that allows you to pass messages from chain to chain, essentially this is what XCVM is. We essentially had to define the instruction set and to create a framework around a pretty already nice framework for doing cross-chain smart contracting. So to actually start this stuff up as a developer, you essentially just need to be familiar with the CosmWasm stack, familiar with IBC, and have a really solid vision as to what is the use case you actually want to accomplish. So how this actually works from a workflow perspective. So assuming you've done all the stuff I just previously mentioned, you then write a single contract with functions as general as like swap, lend, etc., which then sort of are passed to our routing layer, which specifies which protocols on which chains will these functions be directed to. Thereafter, messages are passed to satellite contracts, which contain these different instruction sets using IBC, and relayers are passing these things. So going from one satellite to the next, basically step 1, 2, 3, are all basically passed by relayers, and the intention is thereafter execution happens on multiple chains. So I think it's also very important to note that XCVM is not a rewrite of existing smart contracts and protocols. It's rather just handling state transitions, disputes, and reverts. And so we're not reinventing the wheel here. We're actually like, one of the core components within Composable is really just use what's out there. And so we're using IBC. We didn't invent our own message passing protocol and use CosmWasm as a framework. We did not invent our own smart contract framework. So putting this all together, comparing this to kind of like the OSI model, we have the application layer, which is where XCVM applications would actually live, written in CosmWasm. Then you have this presentation layer, the routing layer, which again is deciding which applications and which chains to route specific functions to. And then you have the transport layer, which again, all of the stuff with XCVM this message passing I was just speaking about is transport protocol agnostic. So we suggest and prioritize the use of IBC, but if someone wants to use Wormhole or Nomad or something else, they can feel free to do so. And of course, everything is then foundationalized by our parachains. So what are the use cases? So I think it's, for us at Composable, we very much so started with like, what's the actual problem we want to solve? And the problem that we want to solve is, can we make crypto and DeFi in the multi-chain perspective feel as though that it is more so of a kind of back-end settlement situation and sort of parallelize it to the UXs that you see in Web 2 with respect to like equities, etc. And when we started building these infrastructure pieces, we realized that we're obviously a significant ways away from this, but I do think that with XCVM, with IBC, we will make our ways, towards actually solving this problem, and we hope to demonstrate this through a variety of these use cases that XCVM can actually power, which previously were not possible. So things like cross-chain lending, which there's obviously examples of with respect to like Aave ports, Aave v3, but you don't have, for instance, a sophisticated rebalancing logic that allows for collateral on one chain to be utilized to take out a loan in an isolated lending pair on some other chain, or maybe even some other protocol. And so this is what allows basically a single front end to be utilized for kind of one specific instruction. I want to take out a loan at less than this interest rate and not have to think about any other complexity. Another key use case as well that's really exciting from the perspective of efficiency for the market is market arbitrage. So with all these different markets in the crypto ecosystem, there's obviously massive arbitrage opportunities across yield farming, across basically AMMs. The sort of use cases there are endless. And I think for a very long time, the reason why applications have not been simple from a specifying what you want to do as opposed to how you want to do it perspective is because it's so inefficient. So our intention as well is to actually demonstrate to people, look, using XCVM, you can now more efficiently make markets across different chains. You can more efficiently route order flow across multiple different chains. And the same goes for MEV. Cross-chain MEV is a bit of a misnomer, but really the idea of passing a message from chain to chain by a relayer really introduces a new revenue model for relayers as a whole, whereas previously they made no money essentially. So in this case, they'll be able to understand what action is causing a reaction and be able to react accordingly. So just doubling down a little bit on what this actually looks like from the lending perspective. So essentially as a developer, you write an XCVM contract, deploy it onto our chain, and specify collateral from this chain can be utilized as to take out a loan on another chain. And so in this example, a user can deposit an LP token. A message is then passed from one satellite contract to the other, acknowledging that this LP token collateral has been deposited, and then the loan can be taken out. And what this actually means, and kind of, I guess, why we're called composable in the first place, is we are essentially composing state transition functions across multiple different ecosystems. I want to shy away from this concept of like a cross-chain sort of like compiler situation, but essentially we're creating a framework where steps on one chain can be broadcasted to steps on another chain, which can be broadcasted to steps on a third chain. And all of this starts from a single instruction set and broadcasted all via IBC through relayers. So I think this is really powerful because for the first time now within crypto, not only will blockchains be able to talk to each other, but blockchains will actually have instructions as to why they're talking to each other in the first place. So I spoke a little bit about user experience and why we actually care about this, and sort of like the original problem that Composable set out to solve. And this is a very sort of simple example of how we imagine retail-facing applications to evolve over time within the crypto ecosystem. As opposed to specifying which AMM you want to use, slippage, etc. These are all things you could select in the settings. The user doesn't need to know any of that stuff. But what the user should be able to do is specify their original assets that they have and what assets they want to end up with. And if they really care about the assets they end up with, then specifying which chain they want those assets on. For instance, in a privacy perspective, maybe you want to exit onto a privacy-preserving chain. So what this looks very similar to is just an email, right? Compose instead of swap. And that's because we're really trying to bring this concept of simplicity for the user experience. So specifying what you have in the initial state and what you want in the final state, and just composing this through a single user-facing application. I don't think there's ever been an example of an application that has been able to connect 3 different wallets and lets you do something like this. And so that's obviously why we're excited about XCVM. So I think there's a huge design space as well within the UX perspective and the actual like product design perspective for cross-chain applications. A lot of times, other sort of bridging teams will focus heavily on technology, but will not really prioritize making the user feel that this is a delightful experience, but rather this is a scary experience for most people. And so for us, for something as complex in the back end as just essentially specifying what you want and what you have initially, we then have created this stepper. And the reason why we call it the sexy stepper is because it's really important for us to make the user understand where he is in the specific flow of XCVM in this instruction set, but also not to feel anxiety, right? Because if you see all of these different steps, then the user can say, okay, like this just feels too complicated, I don't want to use this stuff. And so we essentially do like indentations based to make the user feel, okay, I've now arrived onto a chain, now I'm doing something. And we provide sort of like friendly instructions, names, things like compose and spawn, things like that. So I think overall, what we're really intending to do here for Composable is putting all these pieces together, interoperability, infrastructure, tooling, XCVM, and adding all of these things up, and then investing a lot of time and energy into making the user feel that crypto is a friendly experience to actually own and use digital assets in a trustless manner. And so I think a lot of the time within this space, this sort of like C DeFi world has really popped up at the expense of decentralization, but those things really caught on from because of the user experience simplicity. Things like Celsius, just deposit money, yield, that's all you need to know. These are the types of things that can be built with XCVM, but while still maintaining decentralization. So with that, I'll open the floor to questions.
Check. Thank you for the presentation. My question is, so when you have this kind of generalized instruction set, you know, it's maybe it's like something like assembly type of thing, and you have to do kind of like a transpiling into another like smart contract or VM, I assume that there's a lot of risk for efficiency losses. Mm-hmm. So I was wondering how like you account for that. Like, you know, gas optimization is a big thing in Solidity, obviously. All the ZK stuff requires a lot of optimization for circuits. So yeah, just wondering about thoughts on that.
Yeah, that's a great question. I mean, there's a lot in there, so I'll break this down. So basically, every chain that the instruction set it moves to essentially has an interpreter. There are scenarios where essentially a message arrives and then for some reason it just will fail. Say the protocol that it wants to access now no longer exists, or the liquidity pool has no more liquidity. So that's the scenario in which we have a whole bunch of documentation about reverts, and this is also where the relayers play a very important role, because if we essentially, we intend for the relayers to also play a part in like having a network for people to pay gas through relayers, so they don't have to constantly keep thinking about, okay, I need to swap my tokens to this or whatever. So I think from the reversion perspective, we will have to figure out a world in which we have honest relayers who can assist with like catching these types of things, and also having the developer actually build with failures in mind. So that's a lot of the stuff that we're doing currently at the moment. Our spec, which I'm actually tweeting out probably right after this, has a whole bunch of details about our reversion techniques. Also, error handling is like something super important to think about too. So I think the short answer is there's a lot of this stuff. Of course, like if we had a world in which ZK IBC existed, which is something I believe the Polymer team is working on in collaboration with a few other groups, this would be much more optimized, quicker. The messages would obviously, you wouldn't need a complex interpreter on every chain. But because that doesn't exist, we have this type of infrastructure at the moment. So I think the short answer is we're going to build collaborations with relayers. We're going to have to ideate and really test this out on the wild before we ship it to market. And the third piece is like we're definitely spending time looking at like the ZK scalability implications of this stuff.
Any other questions?
Yeah, you might have heard of Asta Finance and Octopus Network. I mean, I don't really know anything about them, but I heard they're also doing something similar like this. So I was just wondering, like, what is actually fundamentally different between the two approaches?
Yeah, so Octopus and Astar received a grant to build Pallet IBC. So basically to do the IBC work between to bring IBC to Polkadot. They received this grant a year ago. We essentially just picked up their work and continued it. I'm not really sure like what they're up to at the moment. I don't really keep up with what they're doing, but essentially like we also received a grant recently, and we sort of have been pushing a lot of this stuff forward. Not just from the Pallet IBC is like one very small part of the entire bridging story for bringing IBC over. There's also IBCRS. There's also light clients on both sides. There's also working on Beefy. So these are all the different pieces that are making it take a long time for us to finish this stuff. But yeah, essentially the original work was started by Octopus and Astar.
Thank you.
Cool. Okay, thanks so much. Nice one. So yeah, it's lunchtime now. We're back here at 2 o'clock for another series of talks. Thanks a lot.
C et E.
Welcome back, everyone. Hope you had a nice lunch. So our next talk is from Manfred Touron, who is here. Manfred is a core contributor at GNO, which is a new smart contracting, next generation smart contracting chain. And yeah, we're super excited to have him to talk about his project. So please give him a warm welcome.
Hello. Is it okay for the mic? So today I will talk about GNO land, GNO lang, GNO community, everything GNO. Maybe not GNO airdrop, which is another topic. So I'm Manfred Touron. I'm the founder of Bertie Technologies, which is developing a peer-to-peer anti-censorship, anti-surveillance messaging protocol, an application, a mobile application, a protocol, and we're an NGO. I am a cybersecurity engineer and very addicted to open source software, and particularly in Golang. And GNO is a project I joined recently, which is a new blockchain made by people that were already building blockchains in the past. So the creators of Tendermint, for instance. And we try to address multiple problems. We try to make something for a very, very far future, including the lack of transparency that you can see in smart contracts in general, that can bring security issues on CosmWasm, for instance. Lack of fairness and justice with a political approach to make something very for the people. And ultimately, we want to make the platform where it's the easiest and more powerful to build smart contracts. I will make a short version of another talk I gave at HCC about the language, and after I will talk about the Cosmos, the impact of GNO in the Cosmos ecosystem. So here is a quick overview of the language. The language is a full independent L1 smart contracting chain, VM that can be embedded on a chain, no dependence by default. We write contracts in GNO, which is a new language based on Golang. It's not interpreted. We upload it's interpreted and not compiled, so you upload the sources and not the binaries. It's completely deterministic, it's safe, etc. And we design it for the next level of interoperability between contracts and chains. So the vision, we want to make something like Go, which is often seen as one of the simplest languages that power a lot of amazing applications. You have a lot of more complex languages. This one is simple, but you can basically build everything. We want to enforce the transparency, so there is no option to be a good developer. You are, by default, transparent. And we try to make an experience where if you come from the Web 2 world, you can write contracts. So quick demos. The first one is simple contract with one exposed method, which is hello, and another private method. So you write a package like in Go. This code compile in Go, even if it won't make anything useful. But actually, it is a contract that you can call. You publish the contract like on most other chains, so you publish the sources. And a big difference is that you don't upload the contract and retrieve a hash address, you upload and choose a path. So that's kind of a GitHub repository. You upload and choose how you will name the contract. Then when you call the contract, you can just call the vanity name instead of a hash. In terms of data, so persistency, storing, etc., you declare global variables, and automatically the chain will save the state at the end. So in this example, we have a total integer, which is on first publish set at 1000. And then each time someone will call the add function, it will add the value. So there is no way to specify I want to store something. You just declare a variable and it will be automatically stored. We have a special render function. If it's implemented by a contract, it will make basically a web proxy of your contract. So anyone, just by opening a browser or making HTTP request, can get the value. And the value is not limited to just get the integer or something. It's actually real rendering with dynamic parsing, etc. So at the end, you can make a kind of DApp without any other dependencies. In the example, you can see I call greeting/Manfred, which is clearly not hard-coded in the code. And this is a request that won't save the state at the end, that won't cost any gas, etc. Here we start going into the interesting part because GNO is made for interoperability. And here you can import other packages. On most other smart contracting platforms, when you import something, you will import a dependency and you will build the binary. Here you are importing a code that is another published contract. By doing that, you can use the method. You can also write on the other contract, if the contract permits it. And we are not limited to just calling function. You can actually make real object-oriented programming because you can call a structure and call subpath. So at the end, you are not limited to function. You are not limited to simple types. You can go with very nested and complex variables. And so I said that you don't upload the binary but the source, which means by default, you will have all the source available so that the on-first transparency part of the source, it's not possible to upload the binary or hide something wrong. You need to upload the sources. The sources are always available and readable. By default, you upload the test, and then you give some hints on how you want people to use the contract. And automatically, you will get some documentation. So this is very basic, but you can imagine having a smart wallet or anything that understands or discovers the contract features. And you have other examples. So this is just a reminder of GNO Lang, just the language part, which is not limited to one chain, but can be implemented as a plugin like CosmWasm, etc. And now I will speak about GNO Land, which is a blockchain using GNO Lang. So GNO Land is the first blockchain that won't be the only one. At the beginning, is that the only one because we want to not have too much dependence and need to maintain some software for other chains. So we will focus on just one chain with the native token GNOT, where you maybe heard some airdrop news, etc. It started as a fork of Tendermint, but actually it will probably be the base for Tendermint 2. Tendermint 2, which will be a new version with a different paradigm from Tendermint 1. And we plan to just focus on GNO Land, make it production ready, etc., and then maybe extract Tendermint 2. Another mission of GNO Land will be to centralize the good practices of how to write contracts. Since you can import other contracts from any other contract, even from other users, the goal is to make GNO Land the place with the highest quality contracts with review system. So if you run another GNO chain later, you can import the official trusted version of what is a GRC20, etc. And GNOLAND is particular because it will follow the system of proof of staking, but it will be proof of contribution. I will speak about this later. And you can consider the chain like a MMORPG, because technically we just have tools to build new contracts, interact with contracts. We cannot delete contracts, but at the end it's an always growing program which is always running and which can be extended. In terms of roadmap, we are very early, a very small team, and we are actively looking for contributors in general and core contributors to integrate in the core team and to help us define the vision, etc. So I will speak about all the targets later. So yes, at the moment we are focused on embedding developers. You heard about the airdrop. There will be an airdrop, but right now we don't want to embed too many users. We prefer to embed many developers or contributors in general, not only developers. So Tendermint 2. Tendermint 2 is a project. It's not fully defined, but for the moment it's based on everything that frustrates the original authors of Tendermint. Specifically the complexity, the amount of dependencies, potentially the limits of how to develop things. And there is a goal to make an alternative version of Tendermint, which will probably be named Tendermint 2, to keep Tendermint 1 running, because there is a lot of production and there is still a good idea and a good... it's still important to keep Tendermint 1 and its philosophy, but at the same time we will have another version, Tendermint 2. Tendermint 2 will be less modular, less flexible, maybe less performant, we don't know, but it will be focused on making something more simple, something that could live for maybe very, very large amount of years, maybe 100 years without any updates. We want to make something finished. Then come IBC2. IBC2 could be the evolution of IBC with smart contract in the earth, where IBC1 is more focused on transactions. Here we want to make something so you can have real integration between the chains in terms of contracts. So it will be something about reading other chains, but also about writing other chains. You can imagine some kind of microservices where each service is a blockchain. And the ultimate goal is to make a Merkle tree, so you can not only depend on one central point, but say, I want the users of Cosmos. And the answer of that question will be, okay, this is the GNOLAND part, this is the second chain part, etc. Proof of contribution is the heart of GNOLAND community. We don't want to impose this method to other GNO chains, but for us, GNO is like a cooperative of developers that build the chain for other chains, and we want to make the chain itself, the VM that you can reuse in your chains, but also the smart contract, the template, the packages, so you can build a stronger contract on your own chain. So we have a system where basically you contribute, you gain shares. The shares will mint you the native token at the end. So the earlier you contribute, the longer you will have a reward, and the more notable your contribution is, more rewards you will get. So basically, we want to make something where the more you contribute for the chain, for the ecosystem, the more you are rewarded, and then we put the blockchain somewhere, and it's auto-living with the usage and the contributors. The core contributors are a special role. They are contributors. They will continue to earn rewards based on contributions, but they will have some responsibilities in terms of reviewing, assigning, roadmap, helping others, and they will get, like a normal company, some kind of vested shares. So you are elected from multiple years. You need to reapply each time, and each time you gain responsibilities, and you will lead some part of the project. As a core contributor, you can make technical stuff, but also non-technical stuff. And we want to make something between 100 and 334 members, because we think a good big company, a good group is about 300 persons. We would prefer individual contributors because it's easier to monitor the involvement in the project as a standard person. For some companies, it will also be possible. And the contributors will gain more shares, more tokens. They will also have access to some kind of votes dedicated to the future of the chain. And yes, the goal is to make a cooperative, so every contributor is owning the chain or a part of the chain. We want to experiment liquid governance, so not only vote accessible to anyone or for the best stakers. We want to make something where some vote will be more for users, for validators, for contributors, for co-contributors, maybe with some kind of percent. So this vote is 80% for users and 20% for validators, etc. Staking won't be in the core of the chain, but will probably be implemented as a contract, because we don't need staking for the proof of stake. We will do proof of contribution, but staking can be useful maybe to protect something or to create value on the token, but also to make this governance based on staking. Basically, the IBC evolution will probably look like this. So at the beginning, GNO will be connected with Cosmos, with IBC, a standard IBC, non-modified IBC. Then IBC will be extended on GNO to support more advanced features. So Cosmos won't be updated, just GNO and the chain using the extended version of IBC. And then we try to make the IBC2, which is going in the vision of making, yes, an Internet of chain where there is a big Merkle structure. And this is a very long-term project. We want to make something simple, limited in features, but that will stay for a very, very long time. We want it to be a new hub, not a token hub, etc., but the hub of the developers, the hub of the trust, of governance, etc. So it will be a very long chain in the runtime, but we hope to make it a very short chain in the build phase to make it finished at a moment. So we just govern it, but don't extend it. There will be some kind of licensing model, probably. So even another chain using GNO will reward the contributors of GNO. And we try to natively make something similar to GitHub, where you can basically upload your contract in your namespace username of yourself or your company. And then you can gain rewards, expose your code, etc. Right now, you can already try to write your contract or contribute to the core, so as a developer. You can try to develop DApps that will be depending or connected with GNO. You can also try to propose anything that can help the community. Just remember that the current focus is to onboard more contributors, not just more users. And you can join the Discord where we discuss everything. And that's all from me. If you have any question.
I actually had one. Could you talk a bit more about the in the 100 years thing, incentivizing people to contribute and having publishing their code in some GitHub-like thing, and what you think, how you think that could look?
We think that with a share system, there will be a natural dilution of the shares because we won't take your shares back, except in the case of a core contributor that makes a bad thing, so we fire him. But if you gain shares because you made a contribution and we transparently show the shares, then for the lifetime you will gain reward. But the reward at the beginning will be maybe 10% of the chain and progressively will go to nearly zero. So we want to have this part for the chain itself, but then you can imagine also having something not about having shares on the global chain, but just licensing what you made, so your contract, and get some fees on your contract. We plan to make on IBC2 some kind of way to measure the licensing. So by using a special part, at least we make a counter. We don't know if it will be used, but we will make some way to monitor the usage of a package. And yes, at the end, you can contribute right now and gain money for the rest of your life. Just if you don't make anything new, it will go below and below. But you can also imagine just don't caring about the whole ecosystem, just publishing your nice smart contract and expect people to use it.
That's really cool. Thanks. Do we have any other questions? Yep.
Just the GNOT and the shares, it's a token or it's a coin?
I don't understand the
difference. It's a smart contract token?
No, it will be native.
Yeah, native, okay.
The shares will probably be a smart contract, but actually the chain, we have two options. Currently, this is interesting because I learned this very recently. I was sure that proof of staking was very in-depth of the protocol. Actually, it's very basic. You use the chain, you pay gas. This gas won't be distributed right now. It will be put in a big bucket. And proof of staking is the algorithm of taking this bucket and giving it to validators and their delegators. We will do the same. You use the chain, you have some gas, you put in a big bucket, and it will be a smart contract that will look for the shares, because the shares will be a smart contract. We want to make something fully transparent, so you gain share by TX. The TX gives the reason, the author of the shares giving, and the smart contract will probably once per day or multiple times per day take each shares, make a fraction of each shares, and give the reward based on the bucket. So actually, GNOT will be a native token. Shares will be a contracting token, GRC20 probably, and the proof of contribution will be paid by the contract. The chain will be very stupid.
Okay, thanks.
Thanks a lot. Cool, all right. So following up Manfred, we have Stef Sprinz, who's the product lead of the Interchain Builders program. Please give a warm welcome to Stef.
Hi, everybody. So today I'll give you an introduction to the Interchain Builders program, kind of how we designed it, who it's for, and yeah, the Interchain Builders program is the builders program for the Interchain and Cosmos ecosystem. First of all, about myself, a little introduction. I've been with Interchain since the end of last year, and ever since I've been working on the Builders program, designing its structure and the support models that we want to ship to teams. I myself don't have a direct background in blockchain. I studied art, ran an art gallery, and a business completely blockchain or web unrelated. But yeah, I'm in the space for almost a year now and learning. So yeah, today's agenda, we'll talk about the motivation and the why for the program, the program's mission, and then mainly today I want to touch on the structure and the design and the outlook. So let's get started. Yeah, being a blockchain founder is fun at the very beginning. It's exciting, you know, you have a vision, you want to get going, you want to build, and really quickly, early on, you'll come to realize that there's actually a lot of issues. And with these issues comes a lot of anxiety. And yeah, so obviously launching a blockchain network is not the same as launching a regular company. It hasn't been done a million times. There's a lot of implications that come along from really, you know, starting out and like actually launching mainnet, and even worse, issuing a token. So what happens, like these tough decisions, early on, you realize might have huge implications on your project, followed by uncertainty, followed by roadblocks. One of them I'll touch on now, just to give you an example. Very early on, you have to think about, okay, how should you incorporate a blockchain network, company, business? So what we aim to do at the Builders program is to kind of give you examples, give you best practices that we've seen before. Something just to give you an outline here. You want to think about what are the things you need to think about? You know, like what is it going to solve? What problems do you need to solve? Like such as one is in the higher outline, it's about legal liability for yourself, for your team members, in terms of taxations. This is a setup that we've seen before, just an example. There's different ways. So a lot of teams start out with starting a regular company, developer company. What is that for? It's where you start your centralized development of a protocol. You hire a team. It's there you collect the intellectual property to have it all in one place. So you have contracts with team members, NDAs, NCAs with contractors. But you'll also have to have it in place in terms of fundraising, as say, for example, investors do want to know where the IP is collected, is it secured, how does it work? Another step on the way is you want to register a token issuer. This is, sure, as the name implies, you issue the tokens, but it's also in terms of fundraising, so you need to think about, or you should think about it relatively early. It's also, you need an investment company, right? You start talking to VCs, you really like get into contracts. Depending on the structure, you want to sign a SAFT with them, a SAFT, a token warrant, whatever it is. You need a structure, an entity that will sign these contracts with the VCs. This would, for example, also give the VC the obligation and the promise to actually issue the tokens at a later stage, and essentially receive an investment. A third step, as an example, it's also really common to at some point have a non-profit and non-beneficiary foundation to actually decentralize the network. This entity then serves as a legal wrapper for, say, the DAO and for implementing decentralized governance, treasury management. It will hold the treasury, and later how these are connected. So usually this foundation would say, for example, get the tokens from the token issuer once they're launched, hold them in the treasury, and then in the end have service agreements with the DevCo. So don't want to get in too deep. Another one, of course, is for token issuance. You want to think of like, where do you want to, like, what are the jurisdictions? What is the criteria for jurisdictions where you want to issue your tokens? It's really likely not to be your own onshore jurisdiction where you live. So you want to think about what is there in terms of taxation, what are other regulatory environments or jurisdictions that have that in place? What about investor recognitions? Are investors comfortable, or do they know these places and like want to invest in companies that are located there? And also setup and running cost can be really different, as well as the setup time. Like some jurisdictions it might be a month, in others it might be half a year almost. So yeah, that was some detail just to give you an idea. Back to the actual program structure. So what the Builders program aims to do is, so yeah, we give structured support to teams building chains, help them with the complexity of all the topics that it entails, and help deal with some of their anxieties. Then the second part is navigating the ecosystem. As the Cosmos ecosystem is rather decentralized, or one of the most decentralized ones, it's also more difficult to navigate. So in terms of partnerships, infrastructure partners, we help you connect to them. And on the terms of technical support that we give, it helps us enables us to understand better what do teams need, and how can we communicate that to the core contributors to really maybe implement certain features, upgrades. So, who the Builders program is for. As mentioned, it's the Builders program of the Cosmos ecosystem. So it's for Cosmos SDK, Tendermint Core, IBC protocol using chains. It also includes CosmWasm. So this means we're helping really new chains. So either teams who are coming, who haven't even really started and who are exploring whether the Cosmos ecosystem is the right ecosystem for them to build. So really starting from the ground up. As I touched before, how should they incorporate? What are the best practices? What are fundraising strategies? And then, of course, Cosmos and IBC connected chains who need help with technical support, help with growth and adoption, or whatever support they need. And then chains building in other ecosystems who are either looking to migrate into Cosmos or who want to explore connecting to Cosmos via IBC. So the program design, so going high level to low level. So as of now, we have structured it into 6 parts or 6 segments, from going incorporation fundraising, token design and distribution, technical and product support, community governance, marketing and go-to-market strategy, and infrastructure and partnerships. And the idea is that below these high-level areas, there's a lot of details. So we don't want to tell anybody anything that they already know. So the whole idea of the structure of the program is sort of a plug and play. So to really be able to tailor the program specifically for teams, say you're more progressed, you already know what you need, say help with you need connections to validators, you need code reviews, you need, or newer teams, it might be, you need a pitch deck review, or you need you want to get to know some investors and expand your network. You can really plug and play what you need to make this effective. And lastly, quickly about the program structure and how we're working with teams right now. So if you're interested in being part of the program, you can apply through our landing page, join.builders. You'll find an application form. This application form isn't about a hard yes or no, and we look at this and decide whether you're fit for the program. It's more for us to learn what you do, have a little bit of an outline before we jump on an introduction call with you. So going from there, we'll get an interaction call, and from then on evaluate what questions we need to ask, how we can learn more about your program, and after that have a couple deep dives, meaning this is also individual again, so with some projects who are more progressed, who really know what help they need, we can jump right in. With younger projects or more beginning projects, this might even take 1 or 2 or 3 sessions for us to really learn and understand what stage they're at, how we can help them the best, and where do they need to get to. So that's sort of the onboarding, and then coming to the building phase. Once we've figured that out, with the teams, we'll set up a milestone and task list. It'll be accompanied by also individually, depending what a team needs, weekly, bi-weekly, monthly calls or follow-ups, also async question answering, and deep dives on a couple topics that might be of interest, and have sort of workshop sessions. So on another note, as for on the outlook, we're onboarding more and more teams, and the Knowledge Hub I presented you earlier with all the different little modules, we will be open sourcing that in the future. So as we go, this will be published on our website, on blogs. As our knowledge is for free. Our time, unfortunately, is a little limited. So that's the future outlook, what we're working on. So visit us at joined up builders. If you want to learn more, there's also an FAQ, which might answer some of your questions. And then also, in case if you're an investor, market maker, custodian, validator, also feel free to get in touch with us and start working together, as we're working with new teams, and we love to connect you. Yeah, that's it.
Had one. Can you talk about some of the common mistakes you see the teams making when they spin up? Like particularly you talked about when new chains are starting and the legal structure and all this stuff. You talk about some of the big things to avoid.
I mean, what we really see is that what I touched on in the beginning, especially the legal structuring, the whole, what a lot of teams or new teams don't really know or see is like, if you make a map, I had that in there before, but it was just way too confusing, is really when you should start thinking about your legal structure in relation to when you want to launch your token or start fundraising, right? It's like, say you study your fundraising process right now, you want to talk to investors right now, but then you don't even you don't yet have or thought about having set up a company that will actually receive the investment and sign the SAFT token warrant with the investor. So imagine you have the investor on the hook, but this is not cleared out. And that's something, for example, we've been seeing because it's not that clear, especially as it's different from Web 2. You are issuing a token, so it's not the usual equity raise that you would normally have. So that's one thing.
Thanks. Yep. Sorry, I saw that one before.
Just a quick question. Are you guys going to be working with ICS, Interchain Security?
Yes, we will be.
Okay.
So we'll, once that is more progressed and actually launched, we'll educate teams on how interchain security works. And as we're within Interchain and we can also work closely with the hub team, we'll help teams, like whether it's an option for them, if it makes sense, and then also help them onboard to Interchain security and tell them how it works.
Cool.
Yeah.
Yes. And do you also help for a project that is not a Cosmos chain, but like a smart contract with a DAO on a Cosmos blockchain?
Yes, yeah. These are also like with everything within the then I assume it would be using IBC, for example.
Like it's a CosmWasm smart contract
exactly.
with DAO.
Yes, yeah.
Okay.
Yeah.
So.
Cool. Thanks so much. Okay, I see some of our next panelists are hanging out there, so I'm going to go tell them the playtime is over and get them over here. And then we have a panel on privacy up next. Yeah, and there's a fifth chair, the big one. Okay. For Mr. Moderator here. Yeah, a more comfortable chair. And yeah, I'll let you. Yeah,
should all be on.
Test.
And remember to keep them close to your mouth when you're speaking. And yeah, please take a seat.
Is there an order in which we should do it? No.
Richard can decide that. Yeah, there's one more here. Test. Yes.
All right. We're ready to start? Over a few minutes? Yeah. Well, hello, everyone. Thanks for coming to this panel discussion on privacy, building with privacy. We've got a pretty amazing group of people here to share their experiences and their convictions about privacy and what we can do. Just to kind of like open the subject a little bit, some of the reasons why we believe privacy is important. One is to improve the economic fairness of entities transacting. So as we know, asymmetric information can provide one actor with more advantage over another. So that's one reason. Another one is the ability to preserve the fungibility of tokens, right? So if we mark tokens on a public chain as, say, stolen or something, those tokens will eventually be censored and have less value than other tokens. Censorship resistance, and of course, preventing nefarious actors such as governments and dictators from eroding the rights of individuals. So today's panel discussion, I'd like to introduce the panelists here really quickly. So Sajida is someone I've known for some time. She's been working on privacy-preserving technologies for some time. She's a blockchain architect working on social impact projects, most recently one called Hellhound, right? Henry de Valence, yeah, from Penumbra Labs. He's formerly working with the Zcash Foundation and currently building DeFi primitives with privacy built in. And we have Nico Bacca over here, someone I've known for some time as well. I call him the Steve Wozniak of crypto. As you know, he's credited with building the Ledger device. And finally, Christoph Goes, author of the IBC protocol spec, and currently working with Anoma for building privacy primitives on the chain. So, and myself, I'm Richard Catano, co-founder of Accord, and we're building storage primitives on the Arweave blockchain. So we'd like to get into the discussion by just introducing several themes, and then we're going to give the panelists some time to discuss and share their convictions around those themes. So the first theme is, let's just review the space of privacy. What are we currently working on? What's really interesting? Where are your convictions? Where would you like to see things go? Maybe start with Henry.
Hi. Maybe I'll start just with what I'm currently working on, which is Penumbra. It's an attempt to build a ZK DEX, and specifically trying to make it so that it's possible to do private trading or market making. It's kind of interesting, though. I didn't get into that because of I have this deep and long-standing passion for improving market structure or something, right? I got into it because I had spent years trying to build private infrastructure, and had this feeling of it's there's this Venn diagram between projects that people use and projects that are private, and it's actually just two circles that barely touch, right? And although, I'm motivated by, I don't want to live in kind of a total surveillance panopticon. I want there to be infrastructure for people to coordinate with each other privately. That in itself, isn't actually enough to build a useful product, right? And one of the lessons from encrypted messaging and privacy in that context is that if you start out by trying to build this sort of hyper private, super secret thing, but it's not actually usable, then you're just sort of identifying all the people who use it as the weirdos who are using their weirdo privacy tool for their own weirdo activities, and it's not just oh, this is this default thing that everybody uses, right? So the reason that we're interested in trying to build a private trading system fundamentally is here's an opportunity to kind of like change the game a little bit and go from just like, oh, well, this is a privacy product that's, you know, kind of worse, but it's private, so you should want to use it, to here's a product that's actually better at the thing that it sets out to do because it allows people to control disclosure of their information, right? And that's why I think trading is a really interesting use case for privacy, because there's some very quantifiable and like near-term financial value to privacy, rather than just being this kind of abstract, unquantifiable, you know, maybe there's a tail risk, you know, 10 years from now we'll have this like dystopian something, right? It's much more immediate and near term.
Do you think DeFi will eventually all be shielded or in private?
No. I think that there's going to always be a mix. And I think one of the big problems that is kind of under addressed is there's all this work of like, okay, how do we make, you know, this thing private? How do we sort of, you know, use more and more cryptography to make everything like perfectly private? But if you imagine like a DEX, for instance, where every single part of that is totally secret, it's actually not a useful product. Nobody wants to use a DEX where like the prices are all secret. People need to know what the sort of aggregate state of the market is. And so I think that the really interesting dynamic that we'll see play out is like, how do you start like managing the interplay between we want to have privacy for individual actions, individual users, but we want to have transparency and accountability for all of these aggregates. Like one of the really awesome things about DeFi is that because everything is totally transparent and on-chain, you don't have this like if there's like a liquidation, it just like happens automatically. And you can have a very, very robust financial infrastructure because all of the details are kind of real-time auditable for everyone. And you want to keep that while still allowing people to, you know, do things that require private coordination.
Sajida, would you like to share a little bit about your work and some of the technologies that you have been implementing and,
Sure.
and some of the outcomes of those experiments?
Yes. Hi, everyone. So yeah, I really like what you said about basically normalizing privacy and not making it something that like only niche people use day to day. Actually, something that has been guiding my work for many years is how do you reconcile transparency, which is one of the interesting characteristics of blockchain, with privacy, which is something that we need for users to take over, to take control over their data and gain more agency. So how do you do that? Currently, the way that the web was built was not by taking into account at its core principle the privacy of the users. Actually, it's quite the opposite even. It's like, can we leverage user data to make more money? And so when you do that, you exclude the user from the value chain. And so really the problems become, how do you put back the user in the value chain? And so we have an opportunity with blockchain and crypto to do that. So are we going to basically take that opportunity and build the Web3 where users have ownership over their data, their identity? Or are we going to make the same mistakes again, but with more fancy tech? So most of the project that I've been working on follows those principles. I can talk about Hellhound, and maybe in terms of use cases, I will talk about Kinner later. But Hellhound, the idea is to create a blind computation platform, so really a distributed network of nodes, Hellhound nodes, that are going to run heavy computation off-chain and only store proof, mathematical proof on-chain, so that those calculations can be verified. And so by doing that, you can basically send inputs that are going to be encrypted and still get a result. And that's a game changer in the way that DApp and just regular application work today. So basically what you want is for the user to send over their data and know that they're not paying a double cost, which is, you know, maybe the price of the service, but also the fact that now the data that they share, they don't have control over it. It's the service provider that has it. And it doesn't make any sense. When you use blind computation technology, you still can leverage business opportunity, you still can do work, and you're not limited by privacy. And I think that's a common misconception. If we do more privacy, maybe it's great for the users, but at the same time, in terms of business, we are restricted. We cannot share, we cannot develop, etc. And it's quite the opposite. just think about a world where different actors that can be competitors are not scared to share business data with each other or customer information with each other because it's all encrypted and no one is going to leverage that for a competitive edge. But at the same time, by breaking the silos, they're creating a new service that individually they will never have been able to propose to their customer, but by working together, now they can. And so let's think about privacy as a way to foster innovation rather than limiting it.
Well, it seems like from just the both of you, we're starting to see how privacy applies very much so to the individual, but from the collective perspective, we may want to keep some of this data, be able to query it, be able to use it and show indicators of where markets are going, things like that. So it's a very interesting topic to unbundle. So kind of like moving through the themes here, I just kind of want to give everyone a chance and then kind of like dig into some more of the subjects here. So coming to the subject of Cosmos and privacy and dealing with IBC and those kinds of transactions, how do you see privacy rolling out, being integrated, developing in the Cosmos ecosystem, and where do you find interesting projects and opportunities?
Right. Well, I first want to second Henry's point that what we want is not like privacy everywhere in all cases. It is control over where information goes and when. I think the line here, though, is like somewhat subtle, and at least, you know, so a few times this week I had conversations with people who were really excited about using zero-knowledge proofs for like privacy-preserving ads. And it's cool that they're using zero-knowledge proofs, but I'm just not excited about ads. Like making them more privacy-preserving is not, you know, you're fixing the wrong problem, man. So that said, in our case, I work on Enoma, which is a sort of protocol stack for private counterparty discovery and settlement. And especially in the counterparty discovery phase, if you need to discover people, say, with whom you might want to trade, you have to reveal something, unless you're like going to search over all of the spaces of possible people, which is not a tractable problem, right? So you have to reveal a little bit about what it is you have and what it is that you want. And with that information, doesn't matter which cryptography you're using, right? But with that information, some kind of gossip network, in our case, can help you potentially find a counterparty with which you could agree on details and then settle. So here's a case where like users want to reveal information because revealing information allows this kind of system architecture to help them find someone with who they might want to coordinate. But at the same time, you know, all of this information flowing across the network, right? If it's just like completely public, these commitments to what people might want to buy or sell, that's like a great source of data for someone wanting to, you know, do some advertising, right? So I think even in these cases, there's this like subtle balance where you want to reveal as much information as is necessary, but not more than is necessary, and you want to even have some like idea of who probably might be your counterparty, so you can find them and only talk to them, or only talk to people who are probably them, instead of just broadcasting it to everybody.
Would you say that consent is a major like feature of this?
Yeah, I mean, my hope is that eventually we can make privacy so default that no one even bothers to have panels about it. I mean, if we play if you play incomplete information games, which are most games, right? Like Battleship or Dota or Settlers of Catan or poker, no one like has discussions about the concept of privacy in poker because it's so innate to the game that you're playing, and everyone just understands by default. Like you have your cards, you know, you show them, and sometimes you hold them, sometimes only show the back, right? It doesn't require a like conceptual understanding of privacy as this component of this system. It's just an intrinsic part of, you know, what it is that you're doing in the first place. And I think similarly we grasp this in like conversation when you talk to people. You know, you don't say exactly the same thing to exactly, you know, to everyone, and that can sometimes become a problem. But also it's like a necessary substrate for coordination. I think if you had to like, it's so easy to take stuff out of context that, as we see with lots of DAOs nowadays, if you broadcast every single aspect of your decision making and discussions to the world, it's just really easy for someone to misrepresent that. So we want this like tricky middle ground of some privacy by default, some verifiability, some aggregates, price data, some information about how to structure the market. But the line there is not, you know, it's not necessarily one which can be derived from some sort of technical first principles. I think it's also one that's negotiated by culture and society over time.
And coming back to Cosmos, what areas do you see most exciting developments happening in terms of privacy?
I'm very excited that both Penumbra and Nemana and Enoma are working on shielded pools on Cosmos. I hope that everyone will adopt shielded pools on Cosmos. Like, the technology is there, it's free, please go. The next step after that is to, okay, well, if we have many separate shielded pools, then they're like competing with each other, and you have to choose one privacy set or another privacy set, and that's a bit sad because if you know, there's this like, if you choose this privacy set, then that privacy set gets less privacy. So I hope that we can come up with some good like private bridging technology for these privacy sets to interoperate. The other thing, just like as a kind of aside, many applications and where you might want privacy do not like require a blockchain at all. And you know, my guess, and you probably know more here, but my guess is to like why don't these things happen is mostly that like take Signal, right? Signal, you know, does not know, kind of requires like a server, but doesn't require, you know, global ordering and everything, at least in not exactly the same way. And Signal is like a great private application that people in the real world who do not understand double ratchet can use relatively safely, right? Like to me, that's a great example of a success. And at the same time, Signal was built by the best cryptographers and user experience architects roughly in the world, like for this particular problem. And only they could build it. So it's not very accessible. And one hope of mine is that all of this like capital, thanks to sort of mostly the financial use cases in the blockchain technology space, much of which is getting redirected towards like privacy and privacy implementation and cryptography implementation research, will also have this like side public externality of producing much better languages and compiler architectures and proof systems and just sufficiently safe implementations of cryptography for privacy that expose sufficiently like high-level APIs, programming APIs, that developers who do not understand like elliptic curve cryptography can use them to make applications that are private for people safely. Because I think that would be a big win in terms of like how much of the application space, you know, because plenty of people can build applications and can even reason about like data flow if they have a good language to do that, and reason about, you know, what data is private, what data is not private, but they probably cannot figure out like a cycle of elliptic curves for recursive ZK snarks, right? So if we can abstract that as sort of an industry to developers in a way that's safe to use and safe for users of those applications, I think that would be a big win.
There are several like ZK toolkits and stuff, or SDKs that are being rolled out, which could be very interesting in this respect. Yeah. So for Nico, with your experiences building wallets for crypto in Web3 space, it seems to put you, Ledger, in an interesting space between like all of the crypto people and then governments. How do you see government regulation and awareness, specifically around like tax evasion and anti-money laundering, things like that, but how do you see it kind of like developing right now? Where do you kind of see things going? Where are there like a lot of sticky areas to sort out in this topic?
Yeah, so sorry. So I would say that, yeah, we are in an interesting position because we are trying to embed a lot of people into crypto. And well, I like privacy a lot. I mean, for all the reasons that have been expressed before in the panel. And we are trying to make it easy to use for people, and at the same time, I mean, compliant with what the governments, as you said, are trying to push. So we are not going to, for example, we are not going to ourselves to be pushing for privacy technology directly integrated in Ledger Live, because that's something that all the users are connected to. But since we are providing a hardware device which is used to securely sign transactions, we want it to be compliant with all those protocols. And so the way we do this is that while we are not promoting directly, I would say, privacy solutions that can be used to conceal funds and, for example, mixers and that kind of technology, we are an open platform, and we want people to be able to build whatever they want on the device. So now, the problem we have with this is that as a hardware device, as a hardware wallet, we want to protect people's private key, and we want to make sure that they are not vulnerable to malware. We see that often privacy can come in the middle and can actually make the device job more complex when we do that, because when we are dealing with a privacy protocol, we still have to sign the transaction on device, and of course then the protocol will make it hard for the user to read what is included in the transaction, because that's the kind of the way the protocol is working. So we have to rework those protocols usually to make it easier, I mean, or at least split the protocol between the privacy and the security part to make it possible for a hardware device with limited resources to display exactly what's happening and to make it easy to use for people. And so we spend time doing this for simple privacy protocols. So today we did that with Monero, we did that with Liquid. We could adapt it for Zcash as well, because that's something that's just a little bit more complex. My position on this is that we don't want to put the spotlight, I would say, on us, on our users, but we want to support the cryptographic toolkit that can make it easy for people to implement whatever protocol they want. And another thing that I find very interesting, so as you said, is that today we have a lot of capital deployed in blockchains, so this has allowed us to make a lot of advances in cryptography. I would say that even if all the blockchain space crashes to zero tomorrow, we will still have all the cryptography. One funny thing I heard, in a conference, is that, some researcher was saying that the problem they had before blockchain was a thing is that 2 years after their PhD, nobody would care about what they wrote. And the problem they have after blockchain is that 6 months, like 3 months maybe after publishing a draft, there will be already an altcoin implemented supporting the protocol. So yeah, I think that's a good problem to have. We make a lot of advances in cryptography, especially with the ZK proof and so on. Have been able to solve different problems. We can scale, we can solve scalability and privacy at the same time, which is great. And we will be able to use those technologies to push for changes in the real world, I would say. And a good example, if we come back to government about that, is KYC. So know your customer. A lot of people are trying to push for more KYC regulation in the crypto space. And if we are pushed for KYC regulation, we have several ways to tackle the problem. On one end of the spectrum, we have the current solution where everybody is sending their private data to all actors, and you create honeypots of data. You create, a lot of problems when you are sending your documents to a lot of exchanges when you want to interact with centralized actors. You don't know who is going to verify your document, where they are going to go. So that's one end of the spectrum, which is not the one we want. And another one is to say, okay, I'm going to make my KYC with one actor, and then I'm going to create zero knowledge proof of some parts which are interesting for the exchanges, and just send this. So we can do this because we have advanced the cryptography stack enough in the blockchain space to be able to support this. But after we have this, the interesting part is that we can push it back to the financial institutions, where if you look at what happens with your bank today, the KYC is about as bad as it is in crypto. It's even worse. So after we succeed, I think it will be a great way to push it back and to say, okay, so here is how we do KYC in the crypto space. You can do the same for your regular bank, for your neobanks and so on. And so we will be improving the state of privacy of everybody, I would say, with the advances we have made in the crypto space.
So just recently, I think the European Union was announcing some new possible regulations coming down where they define the difference between a hosted and an unhosted wallet. How do you see that factoring into your work at Ledger?
Yeah, so first I would say...
What kind of trouble do you think may come from this?
Yeah, I'm trying to push only to use the term wallet, because I don't think an unhosted wallet is I don't think a hosted wallet is a wallet, so that's... but yeah, okay, they decided to call that unhosted wallet. For us, it's not in the end really an issue, because peer-to-peer transactions are not regulated. I would say it's an issue for the exchanges who want to interact with those devices, and that's where the regulation are trying to push more requirements regarding collecting information when they are dealing with those wallets, and that's a great way for us to push for those kind of new KYCs. So we are trying. If we need to have KYC, we are going to push for less intrusive KYC. So that's definitely where we are going to. So today we have been testing, very simple decentralized identity solutions where we can have those kind of proofs as I was talking about. And you have several companies in the space, already working on this. So I think one of the most interesting one, at least technically speaking, from my understanding, are Polygon ID and Sysmo, so who are basically working on the same frameworks. They are working on generic circuits, so using CIRCOM, and being able to prove, for example, that two addresses can be related, but without revealing how they are related. So that's one interesting way to create a KYC which doesn't reveal additional information about the user when you process it. And yeah, so I would say it's an opportunity for us to push for more privacy-preserving protocols, even if that seems a bit contradictory.
Something interesting you were mentioning as well was the ability for the Ledger wallet to construct the ZK proofs and things like that. And you're able to do some of them, like you mentioned Monero and a few others. Maybe this is also, I'd like to open up for the rest. What are your experiences like working with wallets and integrating the construction of proofs and things, and how would you like to see things develop in the future? It's an open question for everyone.
So we haven't actually tried to implement it yet, but our plan is not actually to do any kind of proving on the hardware device. Instead, you only use the hardware device for doing authorization, and exactly as was mentioned, like you want to separate away the privacy layer from the authorization layer. But now you have this pretty severe challenge, which is like, as a signer, it's not enough to just like have a device that does a signing, right? Because it actually matters like what you're signing. You want to know what you're actually authorizing. And so if you have this kind of like private system where the kind of final transaction doesn't reveal any information about what it does, you need to have a different story about what does it mean to do authorization, right? Because whatever entity is authorizing the transaction needs to actually know what the content is that it's going to authorize. For us, we have this concept of like a transaction plan, which is a kind of, before you create the transaction, you make a plain text transaction plan, and from that you can derive the data that's eventually going to be signed without having to do all the expensive proving or whatever, but you could like, see all the details. Other systems, something similar is possible.
So it's basically user experience issues we're getting into.
Yeah, actually, I would maybe tie that back to a point that Chris made earlier about Signal and the sort of like UX and the cryptography. I think one of the things that makes building genuinely private software really hard is that, even now, you need to have like a team of cryptographers who are designing your like business logic, and that sucks. But it's important because the cryptography is what is like the user experience. Like user experience is not about like how are the buttons arranged, right? It's the whole experience of using the product, and if the product has some cryptographic element to it, you have to align the guarantees that the cryptography provides with the user's like model of what they're doing. And with Signal, right, the double ratchet is this like cryptographic design that is intended to align the underlying cryptography with the actual semantics of like asynchronous messaging. And if you don't have that kind of vertical integration between like what is the user's expectation of how this thing operates and what are the actual properties of the cryptographic constructions, that mismatch is going to cause like a world of pain down the line.
Anyone else?
I would just add that I am very happy as a wallet developer when I see that the protocol is taking care of that kind of complexity and thinking that, the signing part and the signing part need to have additional information because it means less for us, so it's quite good.
Yeah, I mean, similar to it sounds like what you're talking about. We're not planning on doing any zero-knowledge proving on the Ledger device. We were also had some chats with folks from Ledger, and they said they just kind of laughed. But I hope that like in the future things like this may be possible. Enabled by hardware acceleration. The reason like your TLS connections are fast is that chip manufacturers have put hardware accelerators in for the requisite cryptography, and it's completely reasonable to expect that this will happen for some ZKPs within a few years. Just because it's already been said, I kind of want to take a different tack on this question of privacy in wallets. I think right now we have like privacy from the perspective of the ledger name, man. It's so hard because ledger is like the ledger and it's also the ledger and they're not the same ledger.
It was a time where all the companies were called block something or coin something, so we decided to do something different, which is even worse, sorry.
Okay, so the blockchain, right? We can get privacy to the observers of the blockchain, and we can kind of figure out this with some vertical integration of cryptography. We can figure out this UX. But right now, if you use Kepler or you use MetaMask, you are not using Web3. You're using like Infura's database server. There is like zero guarantee that the data you see and the data that you sign on the ledger generally corresponds to the data that you see. Especially if we're doing this like you view it in MetaMask and then you sign it on the ledger, and what that may refer to like contract addresses and stuff on chain. And even if you're authorizing that on a secure hardware device, that data that you just fetched about the blockchain state
you're still leaking.
Well, not only are you leaking it, but it in fact has no necessary correspondence to the blockchain state. It's whatever Infura's servers decide to serve you. So it's just like a trusted party. And in this case, it's clearly users want like programmable indexing. They want to be able to get some computed state from the blockchain, which is not the thing that is actually replicated because it's way too expensive to replicate. It's like many, many indices in SQL, right? And I think in order to bridge this UX privacy gap, we really need some kind of like intermediate proof system where indexers can read the blockchain, prove that they have read the blockchain, do a lot of computation because they're going to be doing computation. We're never going to get rid of that, and make some proof that the computation they did was like the thing that the user expected. And this has to be like integrated into the application programming framework. I mean, this is not trivial, right? It will take a long time. But I think that's one link right now in this user privacy and sort of verifiability stack that is quite weak and will require like many years of concerted effort and standardization.
I think with our time left, I'd like to open up to questions. Is anyone? Oh, okay. In the.
I just want to start by saying thanks for the time. This is clearly an extremely thoughtful group who's spent years thinking about privacy, and it's been, I think, very helpful. My name is Carl. I'm a partner at Six Man Ventures, an early stage Web3 fund. In talking to a lot of protocols, we see a lot of protocols that are interested in privacy, but it hasn't really bubbled up to be the top of their priority list, as in like the number one next feature I need to integrate. And I'm curious, like, what, in your view, which use case do we think is going to first reach escape velocity for privacy? Is it going to be something DeFi and trading related, perhaps peer-to-peer payments, some sort of identity and social primitive? Like, I'm curious where you think we're really going to start to see escape velocity, where privacy or shielding becomes more normalized than it is today.
Yeah, maybe a quick take on that. It's interesting because I remember 4 years ago I was in Israel and talking to Eli Ben Sasso, so the inventors of Stark, and I was wondering like, what is the roadmap, for what he was building? And so to me at that time I was very focused on privacy, and I was quite surprised because he was like, yeah, that's great for privacy, but actually we are going to focus only on scalability. It's like, So is it a bad news? Actually, no, because the thing is, if you ask in this room who cares about privacy enough to pay for it, actually, let me ask you a question. Do you care enough about your privacy to, for example, sacrifice user experience or pay more expensive services that you're using right now just to get that? Yeah. So that's the thing, is at the end of the day, what's driving research and innovation forward is also the money. So if they don't see a direct business model for it, nobody's going to spend funds to develop it. So that's why I really liked what you said about maybe from other sectors that are revenue generating, maybe we can have more funding poured into research that we can then leverage in terms of result to be used in other categories. So that's sort of the way that we hack it now, but I don't think anything is going to happen until we reach the cultural shift that we need, because cryptography has been around for many years. Crypto, like blockchain, Web3 is making it more sexy. Now we see a lot of people working on cryptographic primitives. Most of them have been, invented and conceptualized like decades ago. And it's only because, there are tokens, there is just money in it, and so now it's become attractive. And so I do not think that we are going to be able to introduce privacy by design everywhere. Most people think that it's an afterthought for most projects, as you mentioned. It's like the next thing on the roadmap. If we remain in that state, people have to demand it. People have to say, between two applications, I'm going to select the one that has privacy by design, and then the people building them are going to re-question themselves, maybe.
Yeah, I would say, I mean, I think the costs are different costs, right? They're not all the same costs. And I think people are, right now, maybe much more willing to pay some sort of slight monetary cost for privacy than they are to pay like really bad UX cost for privacy. Because especially if the cryptography and the sort of UX are misaligned and you just can't figure out how to use a system that is private or figure out how to use it privately, that's pretty like difficult to accept as a user. Like you will go use something else. But at the same time, you know, people hate, like if I leave this room and go talk to sort of random friends, like at a club in Berlin or something, people absolutely hate big tech, right? They know that the companies are screwing them over. They know that like their data is being sent around and sold. They know that it's a scam and fueled by advertising. They don't know exactly why or like which are the mechanisms, of course, nor do I. But I think the general cultural background is there to affect a shift, and things just need to reach this like precipice of, like Signal I think has already in some sense, this precipice of sufficiently good UX and sort of sufficient ease of onboarding and sufficient alignment between the cryptography and the semantics of user interactions that they can start to be adopted. And still you see like, first privacy is going to be used by use cases for which it is not a feature, for which it's part of the thing which you are doing. And sending payments or certain kinds of DeFi can be something like this. Playing incomplete information games can be something like this. If you're a journalist or a dissident, or you're sort of living, and many of us are getting ever closer to living under authoritarian regimes, then this starts to become less of a like feature and more of an essential requirement.
And maybe I would say one problem also is that it's pretty difficult to evaluate good privacy. I mean, until you have people in jail or you have other bad things happening. So today, for example, if you look at Signal and WhatsApp, they might look very similar, I mean, from a protocol point of view, but there is one which will try to, run some additional computing on the client, I would say, to be polite about it. So it's quite hard for the user to know what really good privacy is, and I think it doesn't help also to push those technologies forward.
Anyone else? Questions? No? Okay. Well, I think just kind of sum up a little bit of what was just being said here, and our experience at Accord as well, talking to people about privacy. Digital data, the digital domain, those kinds of things are a hit and miss in terms of relatability for average people. And so like, trying to promote privacy as something that can be comprehended, like saying something like, would you want the government to know when you enter and leave your apartment? Would you like a back-end developer to know what's in your refrigerator? Would you like some pervert to know when you're home because they're looking at your electricity bill and know when you come home and not, or on vacation, and try to find you in your bathroom? I mean, there's all these different common sense things that we apply to our apartment that we can also apply to our private data online. And so trying to break down these walls and trying to be a catalyst for the collective conscious, I think, is a really important thing. So I think we're about right on time. So, all right. Well, I want to thank the panelists and thank everyone for joining.
Thank you.
Thank you.
So guys, we're staying on the privacy theme. Henry, who you know now, is giving a talk on his project. So let me just get his slides up.
All right. So yeah, I'm going to be talking about scalable private clients. And this is mostly, the talk is based on the work that we've been doing for Penumbra specifically, but a lot of the kind of design ideas I think are more generally applicable. So although I'll be talking about Penumbra, feel free to take any of these ideas and run with them. To start, it's maybe helpful to give some context for everyone on what Penumbra is, if you don't already know. So Penumbra is sort of a triple of three things. First of all, it's a private proof-of-stake L1 built directly on top of Tendermint consensus. We have our own app on top of that. And what it provides is a cross-chain shielded pool. So you can take any IBC asset, record it privately on this chain. Okay, why would you want to do that? Because it also has a private DEX that's integrated into the consensus so that you can do things like sealed input batch swaps or do private market making. And like I was mentioning on the panel, our thought is that that's kind of an interesting application for privacy because you can build a product that's actually better because it's private and not just, oh, it's nice to have privacy. So this is sort of this like grand vision. You have this sort of bigger Cosmos ecosystem, all of these transparent chains, and then people can do IBC transfers into Penumbra, and once they're inside of Penumbra, everything that they do on the chain is private by default. Okay, so that's kind of enough of the context. But the big question that we have is like, how do you build some kind of like modular, scalable clients for this private blockchain? And the big challenge that we have to deal with there is about state and data models. I think that there's a little bit of a misconception, or maybe it's that people are kind of over-indexed on it. There's a lot of excitement about proving technology. And I think part of that is because there have been a lot of really interesting and exciting advances in proving technology, and that's great. But it's actually still sort of like only one part of this combined system. If you actually want to build a private system, you have to think about like, what is the state, what is the data? So to get into that, let's talk a little bit about the difference in state model between a transparent chain and a shielded chain. So on a transparent blockchain, you basically have a global mutable state. Every transaction says, here's some actions that I'm going to do. I'm going to interact with this contract. I'm going to send this message to some part of the system. That's all transparent and public. And all of the nodes are coming to consensus on those transactions. And then they're applying them to their global mutable state. And on a system like Ethereum, right, basically like the whole world sort of stops for every transaction. That transaction can edit any part of the state. And then you go on to the next one. In contrast, in order to have a shielded blockchain, you have to have a composable state. So a lot of the time people refer to this as like the UTXO model. I think that's like generally a terrible name because it's inheriting a lot of assumptions about the way that Bitcoin works. But you can think of UTXOs as like one instance of this state model. The idea is instead of having this like big global state, we're going to have what the chain consists of is this tree of little state fragments. And then every transaction is going to consume some state fragments and produce some new ones. And the state fragments themselves are generally immutable. And okay, why would we want to have this kind of fragmented system in order to have a shielded chain? It's because, first of all, we can replace all of the individual state fragments with just like a commitment to what that data is. And then instead of having to sort of directly specify what the transaction does, we can have the transaction consume its input states and produce some new ones, and then also sort of seal all of that up inside of a ZK proof that this whole state transition was done honestly. But you'll notice here that these sort of solid squares, that's supposed to represent some data that a user actually has. And the middle one, or the hollow ones, are just some commitment to the data, like a hash of it, right? And the big problem here is that now you've actually sort of, although the focus is on, oh, well, we've made it private, what's actually happened is that you've moved the execution from the full node that's running the chain state machine onto the client. and all of the data has been moved off-chain. Like, great, yay, we win privacy. But now you have this question of like, okay, how does the client actually get that data? How does the client maintain the state that it needs? In this case, you're going to need the client to prove that all of these state fragments that it's using were part of the chain state. What data does it need to make that proof? And that's kind of the problem that we get into with trying to design some kind of scalable client. So there's this question of what do we actually have to do, first of all? So I've made this sort of diagram of this tree of little state commitments. There's two basic problems that a client has to do. First of all, it has to do detection. So if you have this private system where you're not just identifying sort of the sender and receiver of every transaction, a client has to figure out through some other means what of these new sort of states do I actually have visibility into or control over? If someone sends me funds in a transaction, how do I learn that that happened? So this is the problem of detection. There's also this sort of, as part of that, the client needs to maintain some kind of state that's illustrated here in these gray lines, has to maintain some kind of authentication paths for how do I convince somebody else that the pieces of state that I know about are actually part of the sort of global accepted chain state. And in order to do that on an ongoing basis, the client also has to keep this big tree in sync with the rest of the network. So as people have made other transactions, the state of the chain continues to evolve. There's like new pieces of state that are added in. That's going to cause this tree of state commitments to be evolving over time. And in order to prove statements relative to the root of that tree, a client has to keep that in sync. And if we just sort of pause for a moment and think through what that means, actually this kind of sucks because you don't want to have a situation where every client has to process every transaction. You could imagine for us, this is like particularly relevant because you imagine a DEX, like let's say people start using it. You don't want the fact that your product is successful to like cause the user experience to suck for all of the people who are already using it. So how do we figure out how we can sort of still keep our like privacy maximalism, but also make this a little bit more practical? To give a sense of scale, and I could be wrong on these numbers, but it's just in my mind. It could have been misinserted. But I believe that the number of IBC transactions into osmosis is about 100, just transfers into osmosis, is about 100 times more than the total volume of the Zcash shielded pool over like the entire existence of Zcash, right? So if you built a product that could actually get like product market fit, you don't want to end up immediately like suffocating yourself on your own lack of scalability. So the first piece of this, so I mentioned there were the two pieces, which is detection and then tree sync. On the first part, we're trying to build a system that allows us to do fast scanning with delegated detection. So the first part of that is we have the chain build these compact blocks, which is like a stripped down representation of the block that just has the minimal data required to do syncing and scanning. And we actually put those compact blocks into the public chain state so that you can, as a client, authenticate what the contents of that compact block are relative to the block headers. So this is really cool because it actually lets you have, I think maybe for the first time, I don't know, a trustless private light wallet where you can still be, you can keep the kind of like not having to run a full node, maintaining only minimal data, everything that you like about having a light wallet, but also you're not dependent on whatever particular server you're talking to be honest. And the second piece that we've built into the system is a fuzzy detection capability. So every penumbra address contains an additional what we call a clue key, which allows whoever is sending funds to that address to create some kind of probabilistic detection clue. That address has a detection key. This is like a sort of special purpose secret key, but they can send that secret key to some third-party detector, and that detector can examine all of the clues that are in all of the transactions on the chain, and they'll be guaranteed to get all of the true positives, as well as some adjustable false positive rate. And the false positive rate is set as a chain parameter that we can adapt based on the sort of observed message rates. And that way we can trim the scanning work from being, well, you have to scan through this giant fire hose of updates to, we can have somebody else filter the fire hose down to a garden hose. They still don't get sort of exact insight into what your transactions are, but you have a much smaller subset that you're going to be processing locally. And that way you can sort of safely delegate some kind of work to a cloud service without having to sort of lose any particular privacy about your transactions. Once you've got the sort of scanning part faster, though, you're still left with this problem of, well, I have to keep this tree in sync. Even if you could have like perfect pinpointing of what your transactions are, how do you avoid having to be processing everybody else's transactions into this state tree? And to address that problem, we've built the ability to do sort of fast forwardable tree updates. So our commitment tree that we use for these private states has a tiered structure that has these intermediate roots for each block and epoch. So we start at the bottom with this block tree. This is sort of all of the new data that was created in a particular block. That tree is going to be sort of rooted as the leaf of this epoch level tree that groups together related blocks. And then that gets put into this sort of global, what we call eternity tree for like the entire sort of history of the chain state. And the thing that's really cool about this is that let's say you've already solved the scanning problem by doing fast scanning, delegated detection, whatever. Now your client knows here are time periods where I didn't receive any transactions. And instead of trying to process everybody else's data, since I know that I didn't receive anything in this time, I can just immediately skip over this entire block or even an entire epoch of blocks and just completely fast forward having to do the tree updates. And this is really cool because it means that the cost of doing a tree sync is based only on your specific account activity. If you do more, okay, you'll have more stuff to process. But if you're not doing anything, well, you'll only be processing a constant amount of data per time. And so that way, as a user, you get this very nice kind of like privacy without compromise, where if you have some delegated detection, you can outsource the scanning work, and you can skip over processing the data that you don't care about. And that's how you get to having some kind of scalable private client. So we're working on this. We have an implementation of the kind of core algorithms. There's still some optimizations that we could be doing with like even more skipping over stuff. But so far on our testnets, we're able to synchronize and scan through about 13,000 blocks a second, which is like a pretty good number. And to be sort of in a position where that's actually useful for wallet developers, we've structured that into a kind of like modular client implementation. So if you think about the sort of traditional architecture of a client for a transparent chain, we've got, okay, here's the network, there's some full node, there's my wallet, and the full node is syncing some public state from the network, and then my wallet is querying this full node or some RPC provider that's running full nodes. I learn about what my account state is by asking this full node, and then I can make a description of some action that I want to do, encode that into a transaction, and broadcast that off to the network. And if you think about, so this is like kind of convenient as a wallet developer because there's some separation of concerns between the responsibility of doing all this like synchronization and indexing, et cetera, and what I care about as a user of the chain is like, what's my state, what am I doing, et cetera. So in order to try to preserve the good parts of this architecture in a private context, we've actually taken the wallet code and kind of split it up into 3 pieces. So we still have this idea of there's this network, a full node, but now we can differentiate and say what that's syncing is the public part of the chain state. And then we introduce this view service, the wallet, and the custody service. So the software is kind of split out by cryptographic capability. The view service only has the ability to view, and the custody service is what actually holds the sort of spending keys. The wallet software ends up being kind of a coordinator. So you have the view service synchronizing all of the the private state, scanning it. But now the wallet can still be written, as if it was a more traditional, transparent wallet design. It's just that instead of querying like Infura or some other RPC, it's querying some local per user service that's doing this synchronization and indexing. That indexing also gets a lot simpler because you're not having to, by design, you're not indexing the entire world because you can't see the entire world. You're only having to index your own data. Once someone has, this wallet software, and again, I'm using the word wallet, but like this could be any kind of like, trading bot or like an ARB system. We've been testing this with like a Discord bot that we use for a testnet faucet as a kind of proof of concept. That wallet can send a plain text transaction plan to this custody service. The custody service is modeled as some kind of async RPC, so it could be, in process, it could be a hardware wallet, it could be like a cluster that does threshold signing, whatever. And it sends back a set of authorization data, which is sort of like signatures that are going to be slotted into the transaction in the right place. But the auth data actually comes before the sort of final transaction is built, so that the wallet can be, doing all of the expensive proving work on its own without having to involve this custody service. And at that point, it can then broadcast this shielded transaction. But at the point that the transaction is actually being authorized, you have the custodian has complete visibility into what it's about to sign. And the wallet also doesn't have to worry about any of these details of how do I do this like hyper-fast, optimized chain scanning thing. We can keep all of that code common and reusable across all of the different client implementations, and be able to just have like, the wallet focus on what is the behavior that I'm trying to achieve. So that's the end of the talk. Here's the sort of last slide with all the links. If you're interested, happy to chat about it, or you can join our Discord, where we do basically all of our development work. And we run some extremely unstable testnets if you enjoy playing with exciting and broken software.
Hi, I'm curious about the eternity tree and the epoch tree. Is the epoch tree just like lower subtrees of the eternity tree, or is there a meaningful distinction between those levels?
So we're aligning I guess there's 2 ways to answer the question. The first is, in terms of the actual commitment tree construction, it's just a subtree. It ended up working out for us that it seemed reasonably convenient to have all of the trees have the same size. Also, in our implementation, we're aligning we're using the concept of the epoch is also the point at which we're going to be doing validator set changes. We want to be able to not be doing those all the time so that we can like batch up changes to the voting power of different validators and have more privacy for delegations. but that's kind of a sort of app-specific detail. From the perspective of the tree and the scanning, the only detail that's important is that it's a way to create like a group of blocks.
I guess I do have a second question, which is concerning the same tree. To allow clients who may have gone offline at arbitrary points in history to catch up to the most recent state, does somebody, presumably full nodes, actually have to store all of the information that was ever in an epoch and or eternity tree? Or can we start cleaning up some of it?
If you're willing to, if you're willing to kind of like give up on accessing the data, then yes, you can only retain the roots or the intermediate roots, and those are just 32 bytes, so that's pretty small. You could also have the, you could, in our case, we just like bundle everything, like bundle these compact blocks like right into the state because it seems convenient. Another design could decide that that was going to be, saved in some like separate data availability layer or something, and only commit the hashes.
Thank you.
Cool. Okay. Thanks a lot, Henry. Cheers. Nice one. So, guys, we have a break now, about 15 minutes, and we're back at 4 o'clock with another talk.
peut-être partager avec le drive si vous avez accès à celui-là.
Si tu peux le faire, si tu peux le m'envoyer, si tu peux m'envoyer, je peux le faire. Ok. Et arroba, c'est comment? Par grave.
Hi. Are you
Hi.
Parks?
Yes.
Cool. Also nice to meet you.
Nice to meet you too.
Do you have? So yeah. Okay, you're figuring out the slides. It's a French keyboard.
Yeah, I'm just like, what? Where's the, how do you do period? Here?
You have to do shift.
Oh gosh.
Sorry.
There you go.
Yeah, nice.
So just send it right now.
Ernest. Nice to meet you. Tu parles français aussi?
Oui.
Ok.
Mieux l'anglais, mais je vais parler français.
Ok. Tu peux faire ton tour en français. Hein?
Ah, je pourrais le faire, mais ça serait un peu difficile, je crois.
Je vous pose ma même question. Est-ce que tu sais si vous faites une table ronde à...
Ouais,
on est ça. Comme j'ai un micro qui a un peu moins de patates, je voulais l'enlever, mais je vous le laisse.
Mais par contre, je crois qu'on serait peut-être moins
nombreux.
Mhm.
Éventuellement, je te le reprends et puis...
Ouais. Allô? Ouais, en fait, c'est bon, je t'ai appelé parce que... Cool. Hey, hey, welcome back, everyone. So, thanks for coming. Feel free to sit near to the front. So, for our next talk, we have Park Feuerbach from the Figment team with a really epic title, Mother of Protocols. Love it. So, yeah, Park, all yours.
Hello! There's a lot of people in here I know, which I'm really appreciative of. Representing the Cosmos ecosystem. I love it. Great. Glad to have all y'all. Also, some of you who are not from the Cosmos ecosystem, but I'm really glad to have you here anyway. Cool. Okay, so yes, today I'm going to be talking about what is necessary when we think about managing the cosmos as an entire ecosystem. This is something that I think like a lot of y'all are very familiar with, and I'll go into some differences that we see throughout the entire ecosystem relative to other ecosystems. So first of all, what does it mean to have a commons? Is this working? Okay, there we go. So the cosmic commons, right? What is a commons or a public good? Public goods are non-rivalrous, non-exclusive, and credibly neutral spaces. A lot of you are familiar with the concept of a commons from Garrett Hardin's definition of the tragedy of the commons. Not a lot of people have asked what a commons is as a result, right? Big boo, big boo. The thing is, this angel of a Nobel Prize laureate, Elinor Ostrom, solved the idea of the tragedy of the commons by saying that if you just manage custody of the commons in an effective way, then you can get around the tragedy of the commons. Not a lot of people seem to have paid attention to that second step, and so this is something I want to talk about as something that could apply specifically to the Cosmos ecosystem. So the Cosmos ecosystem could use rules similar to Elinor Ostrom's framework, which is defining clear group boundaries, matching rules for governing use of common goods, ensuring that those who are affected by those rules can participate in modifying them, ensuring that authority is equitably distributed, peer monitoring, using graduated sanctions for rule violators, that means just getting punished, dispute resolution, so good discourse in the space, and good governance standards. So I think y'all are also probably already familiar with a lot of these things that already happen in the Cosmos ecosystem, and we do a pretty good job of them in general. In fact, we do a pretty good job of them across the Web3 space, and we're trying to develop better tools for them, but it's interesting because Cosmos seems pretty well suited for it. So the commons of Web3 are a set of open primitives. So what do open primitives mean? Open primitives are basically building blocks that you can use to make something that works. In nature, a lot of open primitives are pieces of a system that are obligatory for that system to work effectively. So that's something like the mitochondria, right? The powerhouse of the cell. I'm sure a lot of y'all are familiar with that great term you learned in biology class. But the reality is that was probably something that developed in nature outside of the system that depends on it, and then became an important part of the system that now depends on it, right? So that became an open primitive. Right? Really, it was really just like a primitive. So they're necessary for systems to function properly as intended or evolved, and are often subsidized through energetic system structure. So that means the system in some way is able to support the existence of the primitive. So primitives are built for optionality. What this means is you can flexibly use primitives to adapt to things that come your way. Mitochondria, as an example, right, would be something that allows you to produce energy as long as it can come in, be consumed, turn into sugars, and then you can use that energy internally within the use of cells. So primitives are also like building blocks that can be used adaptively, like kind of like the primitive idea of a beak on a bird would be a form of a primitive. It's a tool that can be used in many versatile ways. So variation and adaptability are very normal in nature. So it's something that we should also be building into the systems that we are constructing throughout all the ecosystems that we are intending on supporting. Web3 ecosystems building primitives for optionality encourages continuous iteration, and that is something that will help it outlast other ecosystems. So an ecosystem that focuses on building primitives that encourage optionality will outlast other ecosystems. Cosmos, by far, is the only one that has been doing this effectively. So before describing why that is, let's compare this to some other ecosystems, right? Ethereum, a lot of people like to say it's a public good. I don't really think it's a public good, and the reason is gas prices. A lot of things settling to Ethereum also creates a dependence on the core system, which can result in some failure modes. And freedom of communication between pieces of the system is not necessarily straightforward. You don't have the ability to construct and communicate between pieces of the system or outside of the system itself. Polkadot, unfortunately, also not a public good. It does a pretty great job, but it's kind of like a walled garden. You have to pay to get in, and then when you're there, you're golden. But it takes a lot to get in there and get to use it effectively. So unfortunately, the bureaucracy leads to overmanagement in the system, and it makes things move a little bit slowly. So it's not really ideal. You have to also, you have to get elected for block access. You have to be elected in as a validator. That doesn't necessarily make things difficult, but it does create a barrier that makes things rivalrous. It means that it's not an open thing to take part in. Solana is also not a public good. It is built for high optionality, which is something that is really encouraging when it comes to the Solana ecosystem. But it's a closed set of environmental primitives, and it has a dependence on a small set of block producers, which means that you have a high degree of possibility of failure within it, and it's fragile. And fragile as a point to laugh about is also just something that you realize over time, like that's probably not going to be a good place to like keep building things. Cosmos's primitives are a public good. You have inter-blockchain communication, the thing that we're all very familiar with here, the IBC, the ability to communicate between all the chains, right when you set from the outset. You have the Cosmos SDK, which are the building blocks that you can use to take part in the community, and then you have the Tendermint consensus, which allows us to come to consensus on these individual chains without discouraging any level of failure of communication between these things. Nothing prevents builders from building a zone in the Cosmos ecosystem other than using the building blocks. There's nothing that stops you from being able to communicate with other chains as long as you open up IVC channels. And that's huge. That's a big difference from other ecosystems where you have to overcome like other forms of barriers, and you don't have these primitives instantly available so that you can construct and interact with the rest of the environment around you. So the thing is, these open primitives are really useful, but they need to be managed, because otherwise, over time, they're going to probably fall into disrepair, or there's going to be a lack of incentive to continue using them in effective ways, or there'll be a lack of incentive to continue scaling them as the ecosystem grows. The reason that this is something that I think is fine for us to think about at this time is that Web3 is still in a builder stage. We sell this vision that in space, we can start bringing in retail investors, and we can build this space in a way where it scales for the public to use it. But we're really not at that stage yet, right? We're still differentiating all the pieces of the system that we want to use to build whatever comes next. That we're still picking what pieces of concrete we want to use, what kinds of pipes we want to use. We did the architecture stage. We have a good understanding of what we want to build, but we don't know how to build it yet. So we're still in a builder stage. Building these building blocks, maintaining them, and making sure that they're future-proof is an incredibly important part of making sure that whatever we build going forward is something that will be adaptable and highly flexible and highly useful for anything that comes in the future. IBC relay infrastructure in the Cosmos is something that needs to be supported by its community of users. IBC relaying at this time is fully elective, right? So most of the time, relayers are run by people who are running chains. So that's great, but over time, if you have increases in traffic, you end up running into a scenario in which you need more relayers to manage more throughput, but you can't incentivize people to do something that they're not getting paid to do. So this doesn't really allow for the growth of the ecosystem while keeping relaying still free and credibly neutral as a resource to everyone who's connected to the Cosmos ecosystem. So we have to incentivize running relayers. The Cosmos stack needs and will need updating. This is something that we're encountering right now with people who try to build tooling that depends on the Cosmos SDK. And we've dealt with this ourselves as a validator provider. There are just some things you can't do because the Cosmos SDK is built the way it is. But we need to be able to adapt these things going forward. We need to be able to adjust for that. And more importantly, we need to be able to pay people for doing that kind of work. We also need to pay for the work that was already put into it. So one part that I think is really important, right, is we need to give some praise to the people who built these open primitives, because it's a pretty big deal that we depend on them so heavily in the Cosmos ecosystem. But we also need to make sure that they're maintained going forward. So we need to keep a collaborative mindset towards the maintenance of these Cosmos primitives. We need to think about things from a mutualist angle. A mutualist angle means looking at things from a recognition that you can subsidize certain parts of your ecosystem with other parts where you are making a profit. What this means, this is very similar to cooperative infrastructure or union infrastructure, in which people can benefit from their participation in a certain environment through contribution on one side and benefits on the other. So this means that you don't have to turn everything into a fully capitalist fee market, right? If we take IBC infrastructure and we make it so that people are paid on a transaction basis, what we could see is eventually people prioritize relay construction between the chains they're going to make the biggest profit from. And that means all the other chains that are just ideas that are working towards a stage of adoption then get deprioritized as chains that could have wider support, or could be doing something that is not necessarily entirely profit-driven, but still necessary for the ecosystem. So we need public Cosmos native funding institutions. We need something in the direction of making sure that this infrastructure stays credibly neutral and accessible to anyone who tries to enter the Cosmos, because it is something that makes the Cosmos unique to all other ecosystems. And it will continue to be advantageous to people who try to participate in the Cosmos ecosystem. So if we need Cosmos native public funding institutions, we need things like the Cosmos Builders Foundation. The Cosmos Builders Foundation is an initiative being taken on by a lot of people within the Cosmos ecosystem, some core members of the ecosystem who are aiming to do exactly what it is I just described. How is it that we fund some of the core pieces of the ecosystem that we depend on in order to ensure that going forward, we can continue to have these open primitives with a degree of optionality that allows us to adapt to the future? The Cosmos Builders Foundation is something that anyone can contribute to on a builder level, and it means that we can contribute to it in a meaningful way just by being people who are benefiting from the Cosmos ecosystem. So what can you do as a builder? Right? We're having a builder talk right now. There's no sign behind me. Right now we're in the builder room, so what we're under the consideration of here is what can we do as builders? We as an infrastructure provider, what can we do? Well, we can encourage you to contribute. We can also probably contribute ourselves. What can you do as builders? Well, you can contribute to the CBF, or you can establish your own institutions that continue to incentivize taking where it is that you're profiting to pay for things that you need within the ecosystem. So for the CBF in particular, you can contribute some of your funds from the chains from the community funds that you have on the chain that you support. You can help build pieces of infrastructure and contribute to those core pieces. Or you can also take part in the Cosmos Builders Foundation. It's something that I'm aiming to do myself, and it's not like it's a closed circuit. People can definitely take part in it. You can also act on Ostrom's principles. We can begin to ensure that we're living by the principles that I talked about. Right? We understand what the clear group boundaries of the ecosystem are and what it is that those constituent pieces are. The clear group boundaries are anywhere that you're connected to IBC. So if you're in the IBC ecosystem, you have a responsibility to take part in the maintenance of the things you depend on. And that might be, that is a mentality shift, but it is also something that we can do. We can make sure that we're managing that we're matching rules to the governing of these common goods to local needs and conditions. That's exactly what I'm referring to here when I talk about taking part in the ecosystem obliges us to maintain the pieces that allow us to take part in the ecosystem. Going through the rest of these rules, right? These are things, a lot of these things are things we're already doing. We just need to put a bigger emphasis on them. So contributing to neutral public institutions ensures that the Cosmos open primitives remain public goods so that we can continue to benefit from them. So contributing to organizations like the CBF means we put ourselves in a position to continue having the Cosmos as a free and open space for builders to construct in, to experiment in, and continue to scale the Cosmos for. The most important part I really want all of y'all to take away from this is that open primitives with high optionality is going to give us the longest term, most beneficial future for any chain that could possibly exist. The Cosmos is unique in the fact that each independent chain has the ability to build its own zone and communicate with anything else. That communication is something that is encouraged by our upholding of the pieces that allow us to take part in it, right? So if we don't take part in the maintenance and incentivization of the elements that we depend on, we're not going to have a Cosmos that continues to be as free and open and scalable as we have up to this point. So that's my talk. I'm glad to have all y'all here. And I would really encourage all y'all to go check out the Cosmos Builders website so you can have a better understanding of what they're aiming for. And also, really importantly, to be critical. To think about whether or not the approaches that are being taken up to this point are the right ones, whether or not the methods that organizations like the CBF are taking are the correct ones. And if you have some sort of insight on a better way to do it or a better way to be transparent, please raise that. They're easy to get in touch. They're easy to get in touch with. We also at Figment are extremely familiar with a lot of different ecosystems, and because of this, we put ourselves in a position to try to neutrally evaluate where it is that things are happening very effectively. And in my opinion, the Cosmos is an ecosystem in which this is happening. So I really encourage all of you to take part in this, especially since all of us are benefiting heavily from these open primitives that we see in the Cosmos ecosystem.
We have time for questions. Anyone want to ask something? Yep.
Do you think there are specific mechanisms for kind of, given that the Cosmos ecosystem also consists of like a diversity of tokens and sort of economic models, do you think there are mechanisms for routing some of that value to the CBF or other such organizations, and for those organizations to distribute that value to core contributors that are like particularly incentive aligned? Is grants enough? Is it not? Kind of what are your thoughts there on the like incentive alignment of mechanisms?
So in the Gitcoin ecosystem, there's a tool called Aqueduct, right? And I don't know if any of you are familiar with Aqueduct, but the idea behind Aqueduct is that you can automatically delegate some of your inflationary rewards to whatever purpose you want to, right? We should build something like that into the actual validation and inflation mechanisms for every chain that is supported within the Cosmos ecosystem. It's something that would be really useful.
There was a hackathon project called the Allocation Engine that did that.
All right, that's great.
I was just saying there was a hackathon project at one of the Hackatoms that built what the team called the Allocation Engine, which allowed you, the protocol or individuals to arbitrarily allocate staking rewards to any address.
We also implemented that for Penumbra. So.
It's a lot louder than I expected it to be, so I'm sorry. But see, that's exactly the kind of initiative that we need to be taking, is recognizing that because we're benefiting from being a part of an ecosystem that we can take part in without any sort of barrier to access, you should be baking that into the way that you construct your chain. It should be something you're taking on as a duty. So that's huge to me. The mic's falling around.
I'll give it to Gregory
Sure.
afterwards. Is MEV that goes into public goods still extractive?
That's a good question. I mean, there's no reason to not deviate some of the rewards from something that could be democratically used like MEV toward things like this. There's also kind of a whisper where if we had taken things and put them into a fee market with IBC relayers, there's potential for MEV there as well. You know, different levels of incentive for distributing packets through IBC relaying. So that's part of the reason I'm really pushing here on saying, like, we should have a flat rate for relaying. You should incentivize people to run relayers at a flat rate, right? So that way you don't have the possibility of changing a fee market and making it so that people can incentivize certain connections over others. No, well, yeah, that part wouldn't be a market. You don't want to have a market necessarily on the side where you're offering a public good.
Wait, you mean it's not all markets? That's not my question.
It's all coordination.
It's all coordination. I'm curious what your thoughts are in terms of if there is a single commons or multiple commons that we should be thinking about in the Cosmos ecosystem.
Yeah, okay, so one of the things about open primitives, right, is like I'm not making it so that we're exclusive to talking about these three elements that are brought up in here. Other primitives will come about, and those will also become commons, right? And so commons are also just shared space. So however we define commons is something that is necessary for all of us to be able to use and participate in something.
I guess maybe to put a finer point on it, are those three, I mean, I think the three that were up there were Tendermint, Core, Cosmos SDK, and IBC, right? Is that a single code commons? Like, should we be thinking of that as a single code commons, even though those are sort of separate code bases because they sort of require and are complexly interwoven? Or are they three separate commons that need sort of like need us to answer those 8 questions independently for each?
Probably independent, just because each piece is like flexible in and of its own right. IBC relaying infrastructure is something that we should focus on as its own entity. It doesn't necessarily oblige the use of the Cosmos SDK as long as you can connect yourself sufficiently and make yourself compatible with the rest of the ecosystem. And we also see variations of the Tendermint consensus layer that are used on other chains that are still going to have IBC compatibility. So it's really about creating an ease to a barrier of access to participating in the ecosystem, and that's probably more the commons.
Cool. Thanks a lot. Congrats.
Glad to be here.
Good job. It's great to see the builder stage pumping. It's so full. Stay around for our next chat. Feel free to move closer to the front even. We're just missing the speaker. Oh, you're here. Hey. How you doing? Remember to speak closely to the mic.
Okay.
Yeah, have fun. Great. Okay. Cool. All right. Thanks, everyone. So up next, we have Dimi, who is protocol specialist at Stakefish, who will talk about better governance with sub-DAOs. Please give him a warm welcome.
Thank you very much. So hi, everybody. I'm Dimi, protocol specialist at Stakefish and also one of the founding community members at Juno Network. So today I will speak about the governance and in proof of stake system, and especially the ones on Cosmos SDK that use the governance module. Governance as today, you know, in the recent months we had some issues around governance, I say. On-chain governance, we have different proposal types. As you know, you can do community spend proposals to allocate funds. You can do parameter change proposal to modify specific parameters of Cosmos SDK modules. But you also have text proposals that are kind of unlimited powers proposals where anybody can propose anything without any limitation. And I'm not sure if it's ideal. For sure, this kind of governance system is better than nothing, but I think that we can do way better than this. So as we see today, the governance is just one big monolithic DAO where everybody will vote on everything without any distinction. And this causes many issues. For example, in case of emergencies, there is no way to pass through governance proposals because they are not quick enough. One example is in case of a very serious bug is found in the code of the chain, The only way to do that without compromising the chain itself is basically bypassing governance and contacting validators one by one and asking them to basically update the code. And this is not ideal because you are relying on you need to trust on the developers that give you that code, and that's not the best. Also, in case of bugs, we don't really know who will be responsible of what happens. For example, on Juno, we had one mistake by one developer that put one wrong address in a code update, and the funds were like moved to a wrong place. Who should be responsible of that? The developer? You know, that's human error. It can happen. Validators? I don't know. They should they check the code? Should they don't? So it's not very clear who should take responsibility of these mistakes. So some example of the unlimited power proposal that I was speaking about. This is Cerberus chain. I think it's a meme chain. And this is a proposal basically to suicide the chain. And I mean, yeah, with text proposal, you can do literally everything. And thankfully, this didn't pass. It got vetoed immediately by almost everybody. But yeah, this is one example. And the other most famous example is on Juno, the proposal 16, to basically burn the funds of the whale. And this passed. And this proposal specifically was very badly written. And there is a lot to talk about this. I think this proposal generated a lot of hate from the community members to the whale. And basically everybody just voted with their belly and their emotions without really thinking about the future of the chain. And this still reminds us, should be everybody really entitled on vote on anything, or should we split powers of governance in dedicated teams? So yeah, this is the question. How can we solve all these issues that we had? So I would like to introduce you to this concept of sub-DAOs. We defined the definition of sub-DAOs in another governance proposal that it's already on chain and passed. I don't remember the number. I think on Juno is the 9, if I'm not wrong. Basically, a sub-DAO is just a group of people. It can be from 5 to hundreds. Depends on what they need to do, of course, and what kind of efficiency you want. And they have very specific responsibilities. And they have a totally disconnect governance from the main governance. So they have their own voting systems, their internal processes to take decisions. But at the same time, they are still under the control of the main governance layer of the blockchain. So if anything happens, the main governance can still somehow overwrite or disband or change the people that is part of this sub-DAO. Another thing that sub-DAOs can do, they can have, they can trigger specific actions on the topic that are relevant to them directly on chain. And of course, to do this, you need to modify a little bit the protocol of the chain itself to give them this kind of powers, but it's something that we can totally do. And another interesting thing is that these sub-DAOs, they can get paid directly from the on-chain community taxes. I mean, if you know all the transactions on Cosmos are part of the gas fees, it's already used by the protocol in the community pool. We can maybe split or change the percentage to allocate to different sub-DAOs. And at the same time, if one of these sub-DAOs don't do their job or they act in some malicious way, they can get fined by the community itself, still using the normal on-chain governance system. So some sub-DAOs example that I would like to see in the future, and actually I'm working actively in specifically in the security DAO. Security DAO, or we can call it infrastructure DAO, still have to decide. Basically, before I said, who will take responsibility of the code shipped on chain? Because of course, I mean, everybody has a little bit of responsibility, both validator and core teams, but we can have an entity that is specifically addressable for these kind of things. On Juno, we will soon have multiple core development teams, and so we really need someone that takes responsibility if anything bad happens. So the security DAO will have the responsibility to audit and double check all the code that gets deployed on chain. If they don't fulfill their job, they can be fined by the community. And another interesting power that I think the security DAO should have is the possibility to trigger security upgrades without passing through the on-chain governance. So let's say a very bad bug is found on CosmWasm. They can trigger an upgrade maybe right the next day, or in 2 days, or in a few hours. All these things we need to decide using some kind of parameters, of course, but in this way it's way easier to coordinate validators to implement the new security patch, and there is no need for a voting in this case. We already have this group of people that it's competent enough to say we need to upgrade for this specific to fix this specific security issue. And at the same time, the main chain governance can vote to cancel an upgrade. So in the case this security DAO act maliciously and they say, okay, let's trigger a security upgrade that in reality is not fixing any security issue but only getting us a lot of tokens. If this happens, the main governance can create another proposal with a new proposal type that will have maybe a very short voting period but some kind of high quorum, and will cancel the security upgrade and at the same time disband the security DAO, removing all the powers to them. So this is something that I think could help a lot in validator operations and also the security of the chain itself. Other sub-DAO examples are the investment DAO. If you, especially for Juno, if you look at the current situation, during the bull market, the community pool had a lot of funds available to fund the developers and projects. And now, during the bear market, it's not that much money to sustain a chain. And I think this can be prevented by having a specific DAO that can maybe manage part of the funds from the community pool, converting stablecoin in strategic time periods, these kind of things. This is, of course, open to exploration. It's just some kind of idea, but I would like to see some work on this front. And another thing that instead we are already working on is the delegation DAO. Right now, Juno has we have the community pool that it's available to everybody through on-chain governance, and there is the core development fund that it's managed by a multi-sig of 5 members only. And this is not ideal. So at least for the delegations, we can have a sub-DAO that it's authorized from the core team multisig, the development reserve multisig, to manage the delegations in their behalf. And this can be done using the OutZ module of Cosmos SDK, so it's very easy to do. And the DAO can decide some specific delegation programs, and they can do everything from a very easy UI that it's DAO. If you don't know DAO, it's one project that it's built on Juno network that allows you to create DAOs and manage them using a UI. And all these sub-DAOs can easily be smart contracts on DAO just to simplify all the operations. So another thing that I would like to see in the future is a way to limit the text proposal powers. So as we said, right now you can just write whatever you want on the text proposal, and if it will be voted, in theory, developers should develop what is proposed in this text proposal, and then you will proceed with upgrades. I think we should kind of limit the powers of text proposals, and to do so, the best thing we can do is having some kind of guidelines or constitutions or some kind of principle that the community will agree in advance. So basically, we will have a text proposal saying, hey, these are our principle, and we will not go out from it. And this kind of principle or constitution should try to predict every single case. Like we already had one proposal to burn the funds from one wallet, so we can say, we can write in the constitution, we can say maybe, no, burning funds from a wallet, it's totally forbidden. There is no way we can do that. Or you can write, okay, there is this specific process to achieve that. And all these things can be decided in advance and agreed by the community. So in the future, we will not have any more proposals that are totally out of control from nowhere. And if you have this kind of constitution, you also need some teams that are ready to defend it. Because, of course, it's easy to say, okay, let's follow these guidelines, but then if there is nobody willing to defend this principle, nobody will care, right? And this can be another sub-DAO. So we can have, or multiple sub-DAOs. Yeah, the open question is who should write this constitution, and I think that multiple parties should do that, and they can either collaborate or propose different constitutions, and the community will decide the most popular one or the one most in line with the general thinking of the community itself. Yeah, so this was all I got. Thank you so much. Any question?
So you mentioned some of what you're implementing in Juno, right? Or in some of the new approaches to governance. Are there other projects that are taking on some of these?
So yeah, I was using Juno as an example, but for example, for the security upgrade, I mean, I think it's important for CosmWasm permissionless chains, because of course a smart contract chain is more subject to constant security upgrades, but also all the other chains have security upgrades every once in a while. And so for example, making that process easier and simplify validator operation is very important. So even if you don't have DAO or you don't have smart contracts, all of these is still can still be applied basically to any chain. You just need to develop some kind of module and having some kind of subgroup that can handle this stuff. So I use Juno as an example because it's where we are building this in the first place, but it can be used by any chain.
Very cool, thanks. Any other questions? Cool, thanks a lot, Dimi.
Thank you.
They're on there now. Yeah, they're all sitting there now.
Check. Hello. So we can maybe do introductions and then we can get into questions. But this panel is about power in POS blockchains. Are they properly balanced? So my name is Daniel. I head the protocols team at Stakefish.
I already got the mic, thanks. So my name is Adrian. I'm running Stake Lab. So it's a validator on Cosmos ecosystem. We run 51 chains actually, and basically that's it. And also I'm working at Leisure since 5 years.
Hey, I'm James Perreau. I run the venture capital fund Figment Capital, and also obviously it's part of a larger company called Figment, and we're a proof of stake infrastructure provider that runs over 60 chains and I think over 24 in the Cosmos ecosystem.
All right, hey, I'm Felix. I'm the Chief Commercial Officer at Chorus One, also a staking provider, active on a little bit fewer chains than what was mentioned here, but around 30. And yeah, super happy to be here and like discuss this topic.
Hi, Ron. I think you know me as your MC for today on the Builder stage. I'm also co-founder and Chief Product Officer at Kiln. We're a staking platform like you guys. We're on even fewer chains than you. We're on about 15 chains. We've been very Ethereum focused the last few years, but now we're broadening our reach. Yeah.
Cool. So I think we could just start with the question. Do you think, it's a yes or no question, do you think power in POS blockchains are properly balanced? We just say yes or no, go down the line, and then maybe we can discuss it a bit.
I think so, yes.
Maybe.
No, it's a yes or no, Jim.
Oh, sorry. Yeah?
I'll take the no, just.
Okay. No. So we have two and two. So maybe you want to describe why you think it is balanced.
Okay, so let's start like with the overview of this, like how is it working? So basically, in the Cosmos ecosystem, if you don't know, it's working with validators, and validators represent a voting power. The more you delegate to a validator, the more voting power he got. So if he, on his side, try to say yes on a governance proposal, it will basically, if he has 10% of the chain, put 10% in a yes for the proposal. But the thing is, actually, if the delegators decide to overwrite and just put a no, then the power of the delegator representing by his shares directly goes to the no. So it changed the vote. So for me, the Cosmos ecosystem is quite like well educated. There is like ton of tools working on it. So I think I said yes because even if like validators got 10%, most of the delegators have their own opinion and basically just vote on it. If you just check, for example, on the most of the ecosystem, even on Cosmos, there is like on each proposal, I think like 50K approximate of people voting, so it's quite a lot. And if you compare to the Ethereum ecosystem, it's just like 1K or something like that. So,
what share of the token supply is that, roughly?
What do you say?
The share of people who are actually voting, would you say?
Yeah, I was meaning like on the amount of people just like basically voting on the proposal. Like it's not really well done in the Ethereum ecosystem. But on Cosmos, I think like with all the airdrops that have been made and the fact that if you vote sometimes on the vote, you get an airdrop. So yeah, I think they're used to. And for this reason, I think it's quite like okay, I would say.
I guess like, you know, proof of stake, when we're talking, just to clarify here, when we're talking about proof of stake and we're talking about like power and imbalance, like we're really focusing mostly on the Cosmos, right? Like Ethereum is still like incredibly new to proof of stake, right? Like, and so the only place where like governance and on-chain governance and proof of stake has really cut its teeth is in the Cosmos ecosystem, right? And so the experiences and the maturation of the entire ecosystem, like of proof of stake focuses squarely on the fact that like the Cosmos ecosystem is like where it's all happening right now. It's ahead of its time. I'll keep saying that at every panel I speak at. And so like, is it like I think like the idea of like whether it's like balance or power, like is a power balance, like depends on a number of questions that you're asking. Whether it's like governance, whether it's like the investments and like who's holding tokens.
Let's use governance first.
You want to use governance first?
Questions later for you.
Yeah, sure. And so like I think governance is like a super interesting one. I think and like even when you look at proof of stake on Ethereum, it's not a governance token. Like it's essentially like the way that decisions are made in Ethereum versus the way that they're going to be made in Solana versus the way that they're going to be made in the Cosmos ecosystem are very different. The most interesting thing are like the governance thing, like the governance decisions that are being made in the Cosmos ecosystem. You can agree with some of them, you can disagree with some of them. Maybe we can talk about a few of the ones that we disagreed with at some point. But ultimately, like it allows users that are staking their tokens to vote, and if you don't vote, then you essentially are like you're essentially delegating your vote, similar to like how representatives in governments work. That you're like when you delegate to Figment or you delegate to Chorus One, or Stakefish or any validator, you might be thinking about it from the perspective of like I'm getting charged a lower fee. But what you might not recognize is the fact that like you're letting this other person vote on your behalf if you're not someone who actively participates in governance. And I think that's like something really important that like sometimes gets overlooked.
Yeah, I think I was the one that said no. I guess we're talking a lot about the systems that are in place in Cosmos to allow for power to be balanced in a way, and they are definitely there. I would agree that the mechanisms exist to the largest part. Maybe we could discuss like, does it just need to be a validator that you can delegate your vote to, or could there be like other parties involved in this too? I guess that could be like one feature that is added, but in general, they are very far ahead of the time in terms of like other ecosystems. But I guess, yeah, in practice, is the power balanced? Probably no, because yeah, there's a lot of problems with, I guess, also token distribution, who holds the tokens in the first place, and apathy, and like your vote doesn't matter, you just don't care about it, and like yeah, a lot of things that make it in the end not so balanced as it probably could be. But the mechanism is there. I would say that.
Yeah, I think I said no for the similar reason. I mean, the one to add is like the active set to get into, you know, to be a validator in the Cosmos chains, I think has an impact as well. And that's something that, you know, I think Ethereum does differently. Anyone can run a validator. And yeah, I think that there's probably some interesting things to do around other delegation constructs than just, you know, one-off delegation of votes to a validator, maybe some substructures for delegating for certain topics to certain people, like kind of a representative democracy type of thing. But yeah, I would say I agree with what you said. Yeah.
Do you think that type of representative democracy is a good balance? Because you're describing, right, if people have the ability to like change their votes as opposed to like what the validator they're delegating to is voting on, like that is that ability to exit from who you delegated to. But that's great, but then does it even make any sense? Like, does it actually make an impact? And if that balance is, if you have a balanced ecosystem that is balanced, you want that balance to represent the power to do what you just said. Right?
Yeah, I think there's like two different types of validators, and we should probably be clear about like the types of validators that exist in the space, right? You'll have like enterprise grade validators, right? There's institutions that are staking to Figment, right? And the organizations that are up here, and we're all trying to like, and so institutions are delegating to us because maybe they don't want to participate in governance, right? Or maybe they trust us in the way that we think about how we're governing. And so as a result of that, we find like that we have like the obligation to be very clear about how we're signaling why we are voting the way we are, right? Like with the like supporting Terra and then not supporting Terra, right? Like we published like specific language and like thought about it a lot, and then went publicly and said, here's why we are going to stop supporting that ecosystem, right? There's also like core devs that are validating on these chains, and they're doing it for like they've contributed to the code, they're gonna run their own validator, and you know what, you should delegate to them as well, because like they are making the network and the ecosystem better. And so like you should be delegating to them as well. And so that's a different type of person and a different type of token holder that might be able to delegate their tokens to that validator, maybe because you appreciate how they're thinking about the space slightly different. Maybe because you think that they deserve some like economic incentive for like the work that they've done. But like there's essentially more than one type of validator out there, right? And like we should like really think about like how we're delegating and making sure that we're doing it in like a responsible way, depending on like who you are and what you're like, how much time you have and like what your value, like what you value.
I want to. Does anyone have a comment on that statement?
I think, yeah, like one thing I guess worth mentioning is that, yeah, many people, like governance is a complex topic, these blockchains are complex systems, and there is, we are very close to the problems, and maybe the core engineers too, right? The validators that people delegate to, people trust that we understand it better, can make a better choice than them, because they just don't understand the problem in the first place, which is also like an education problem, but also just a time issue. And so I think, yeah, that's why people do it, and yeah, it makes sense.
And people like look to Chorus One, right, for like where like it's a signal, right? And they look at like sometimes hopefully they're looking at Figment as well, right? And it's like, what are you contributing? How are you explaining your position? And like other validators that maybe are a little smaller, right? Like and don't have as much time, like they want to understand the situation, and maybe sometimes they can't like fully spend as much time. And so like by seeing how we are thinking about the space and disclosing it, it allows other people to like. It gives a signal, and it also helps people like frame their own, make their own decisions.
Yeah. So you brought up really interesting points around, right? Validators are communicating with each other, right? You guys get to see like what actually happens behind closed doors, maybe, right? You're saying like, hey, you'll get a DM, and it's like, what are you voting on this proposal for? And then is it just like a follow the leader kind of concept, or you're seeing like someone votes on a controversial proposal, and then everyone just like, right, that one domino falls and everyone else does. But like the point that you said, if there's a core dev that is also running a validator, right? Part of like the existence of these independent third-party validators from these foundation teams that created the code, the core devs, like the independence is there for like a check and balance. So then if there's a core dev that's running a validator, where is that check and balance coming from? Is he checking himself? Or like how do you separate that, right? Because if they're not, then you might as well just put them under one entity, under an umbrella.
Good question. So, I mean, I think these core devs, right? I mean, like someone who's contributing to the code and is like working and like maybe producing some content, and is also like I think Jakub's a good example, right? Someone who's like core to like the ecosystem of the cosmos, does a lot of goodwill, generally, and also like and runs validator. Like, do you want to delegate some tokens to him? Sure, you should, right? Cool. He like is adding value to it. No, I mean like I think like we've asked like a different question, like you were sending around some of the questions, and one of them was like, oh crap, I forgot what the question was. But no, I think like you should be able to contribute to you don't have to delegate all your tokens to one validator, right? And so like you can like level it however you want to, and you can like delegate to a number of different validators within the same chain. You can delegate your rewards to a different validator than the ones that your principal investment is to. So I mean, it's not like a all or nothing like sort of answer. I think it's like nuanced, and it should be, and like, you should kind of spread it out a little bit.
Yeah, actually, you put a good point. Like usually, the delegators thinks like the easy part, like the ease of use. So I'm gonna put like all my bags in the same validator. But the fact is, even like in any financial things you're gonna do, if you put your bag in one token and it crashed, then you lost everything. So you should just like consider as a delegator, and even if you're a company or anything, to distribute to the contributors. And actually, there is tons of good contributors, as you said. Even Jakub is a very nice one. But there is something like you should separate. There is kind of like here in the panel we have, for example, Kiln and Figment, and they run validators for other people. That's right. So you're running infrastructure for others. So it's kind of like centralization in some part, because if Figment goes down, then there is like tons of validators that goes down as well.
So you're saying like whitelisted validators? Or you're saying like there was like a tweet that was like, how many validators are Figment running? And
yeah.
It was like, well, there's two. There's one that says Figment, and there's one that says Ledger by Figment. And it was like, that's a non-issue. Like, let's be careful here, right? I mean, but like ultimately, like, look, there's validators who run multiple. Like, even if you run one validator and it's on AWS, and everybody runs the validator on AWS, well, I guess if Amazon goes down, then like we're all screwed, right? So
yeah, it's true.
So that's a centralizing factor as well. We typically aren't running a lot of white labeled validators, is what I would say. Funds that want to, like funds or investors that have like some access to and want to run their own validator, maybe want their own name on it. There's definitely like best practices that can be taken in order to do that. One way would be to like make sure that one validator is running in a different geolocation than another. Another one would be to like run one on AWS and run another one in like maybe Google Cloud and another one in bare metal. Like there's ways to like make sure that it's like not completely like central point of failure. But I don't think there's like a lot, like most organizations are not running like 5 validators out of 100 or something like that. That would be considered probably like not best practice.
I would say one big centralizing force is just the nature of the active set, right? Like you look up the list of validators, you probably delegate to most people probably delegate to someone who's up there, right? Because they're not likely to drop off the active set, right? I think that's a pretty big problem. Also for new people, new teams to get involved and start running validators, like you basically have to be early, right? You have to be early to contribute. I think that's the biggest probably centralizing factor.
Just to add to what James is saying, like I think most of the this is maybe a little bit bearish talk, but I think most of the ecosystem and those institutions do be responsible. They're like Coinbase is not only using one validator. They have like a good mix of a lot of those things. I have a question for you, because you're coming from the Ethereum ecosystem a lot, right? There are multiple, like let's say core dev or client teams that do run software for these types of validators. But then when that balance between many different clients versus what we have in Cosmos, how do you see that coming from the Ethereum side? And then now it's just like one follow the leader kind of as a...
Yeah, I mean, I think like at all layers of the stack, you need to have different options. It's just like you were saying with AWS, right? We need to have different cloud providers, different hardware setups. In Ethereum, there's like 3 or 4 validator clients that are good, and there's a dominant one, but like it's something everyone tracks in like Prism dominance, right? Like, and then you need the same kind of thing at the level of liquid staking protocols as well, right? Because that's also something that's happening on all chains. So yeah, I mean, I think it's important to track those dimensions.
Yeah, I will just add, I think in the end, it's the market dynamics, right? It's just a business as any other in a way, and where there are incentives, like someone will like build the product for it, and I guess it's a competitive landscape. People try to build the best product, and by nature of doing that, they will automatically decorrelate their setup, make it more secure, that it's actually like these factors that maybe be problematic, kind of make them not so problematic in a way. And I think, yeah, you cannot really like influence that market dynamic so much. It's gonna happen. Maybe you can try to do certain things, right? Like tracking, I think is a good point, like trying to raise awareness of certain things that are happening, or if someone gets too big. But I would just like to add that and just see it from that perspective.
Yeah, you brought up liquid staking, and I think now with like the passing of Proposal 72, we will have like this consumer app chain with Neutron, which is eventually going to bring, I would assume, like liquid staking through Lido. And Lido had its own fair share of controversy, right, on Ethereum. They control over 90% of all liquid staked ETH. And then there was that sort of conversation that they had where, are they going to voluntarily curtail themselves, or are they going to allow other options? So like, I mean, that is also an example of like power balance where you have a few particular individuals, and I think most of us are node operators for Lido, right? And that those decisions may not necessarily be reflective of the entire ecosystem of Ethereum, but they were made regardless. And I think, right, there was that assumption that Lido would kind of stop itself because of what had happened in 2014 with Ghash, with the Bitcoin hash rate, but then in this case, it wasn't, right? They advocated for more competition. So I'd be really curious to hear, right, that is like a borrowed concept, an analogy to sort of like the key decision makers in these ecosystems. Many of you guys are one of the largest in Cosmos, right? And a lot of the Cosmos SDK-based chains, right? If you advocate for competition versus just like voluntarily giving up or redelegating to other smaller validators, what is your sort of stance as an organization for that?
I mean, we all know each other. We all like each other. I think, I hope. Yeah? Okay, thanks.
Sounds like collusion,
I was
Jim.
a little worried there. No, but I mean, I think we all like each other, right? We collaborate, and I think it's like not a winner take. I think decentralization is not winner take all. Like, right? It's like a rising tide lifts all boats, and I think that we think about it that way. We like message each other in public. We message each other like in Telegram as well. But like, I think like Commonwealth, one of the coolest things about Commonwealth and like in crypto Twitter in general is that like people do their best thinking and their best decision making like in public, and it's really cool to see. And like that, like you can get challenged and be like, you know what, I was wrong. Like, and I'm open to being wrong in public. Hopefully, people remember when I'm right in public as well. But I think like it's. Like Lido is like a really interesting one, right? I mean, I think like Lido is a good actor in the space. Number one, right? Number two is like they gave governance rights not just to the LDO token, which essentially would centralize like staking for Ethereum, but they also like started to give like they thought about it a little bit more and said, you know what, SDETH, they deserve a vote also, and I would agree because I don't have any LDO tokens, but I do hold SDETH, and I would like a vote on like how the protocol is run, right? And so like I think like as long as like steps are being made in the right direction like that, like that's a show of goodwill that like should be kind of considered and like and appreciated, I think.
Yeah, I think totally agree to that, and yeah, keeping people accountable, open, right, transparent. You have it's right the core concept of blockchain. It's open source, and we can see how the systems work, and we can kind of intervene if it's not working as it should, I guess. But I'm taking it back to the whole question: should it like centralize, or should they kind of limit the power, like Lido in this example, or in general, should you do that? Again, I think like market-wise, probably no, and I think it's also a problem that in the design of the protocol designers, so I'll stand for this, where it's like, well, the protocol designers try to like form the market in a certain way where it was in their heads, like we need the home staker, so we will do this weird staking design like this, and it will play out like this, but the real world was very different from their theorized kind of ideal, and then Lido came along and like fixed the problem that was there, right? Like staking basically wasn't good for Ethereum, and then Lido made it great, and it's great for ecosystem, like more staked, and they got the reward for that in terms of like a lot of TVL, and it's a good product, but you could have prevented some of that. I would say this is like my opinion, that if you like design your protocol already with that in mind, that this will happen, like you have to watch the reality of the other ecosystems also and see what's happening there and kind of take these lessons, and I think some of the protocol designers haven't done that so well in the past, and yeah.
The other thing I was going to say, like, really quickly about governance, like, it's so weird is that, like, you know, you can have, like, I'm going to have carrots for lunch today, right? And I vote, and, like, everybody votes, like, 60% yes. And it's like, I don't want carrots for lunch. I guess I'll just, like, propose this afternoon that I don't want carrots for lunch again. And hopefully everybody votes no, right? And it's like, the idea of, I forget the term for it, but essentially, like what is, like, when someone votes yes or no on something and it passes with a majority opinion, that, like, is that the end all be all, or do we, like, just keep voting on it until we get the answer that I want, not the answer that, like, particularly is, like, probably best for the ecosystem? And I think, like, we've seen that a lot with
Brexit.
Yeah, Brexit's a great example. That's, like, off chain. So that's a good example. There's, like, other ones as well. I think, like multiple times with Cosmos. Like, if you then, like, when Terra went into, like, ultra print mode and there was just way too many Luna and everybody could vote on everything and propose all these different crazy, like, proposals, right? It was like, oh my God, like, my Telegram is blowing up with, like, all the votes because there's just, like, so many things, right? And so I think, like, best practices kind of need to be started to considered about, like, when we vote on something, like, what's the timeline before we can vote on the exact same thing again? It's kind of crazy sometimes when you think.
I have maybe one last question for you all, and I think you're bringing it up a little bit, right? The initial set of validators that get established when new chains pop up is quite rigid, it seems like. And that is also right around, like, this power balance and who governs these chains, and it usually is sort of like the usual suspects. Like, you guys are always there, like, we are there often. How do you see that changing? And, like, right, you were talking about, like, efficient markets, right? You should see this sort of redelegation. But yeah, I'd be curious as to, like, how you guys are thinking, if you guys think about it at all, right? If you don't want to curtail yourselves on purpose and you want to see other competition, but then it's like you get the pitch deck first to, like, invest, and then you get, like, invest in them, and you get, like, incentivized testnet tokens and more foundation delegations because they want to be friendly with you because you can support them. So I'd be curious as to, like, all four of your opinions on, like, what should be done with, like, these actually inefficient movement of tokens and redelegation on validator leaderboards.
Well, it's quite hard to say, like, okay, you're delegators, you should relegate to just, like, create something quite decentralized. So you mentioned the fact that if there is, like, a new blockchain, it will start, like, completely differently, totally depend on foundation. So the foundation will decide, like, first, do I need, like, some invest? If they are raising, then okay, the top validator set will only be the people that invest on it. If there is, like, an incentivized testnet, people will have, like, kind of token, but most of them are just not really known guys and literally just drop off the set, and after that complain about it, obviously. But the fact is, yeah, it's a decentralized world. Like, if someone wanna put, like, 100 million on the table and just be first and try to have, like, most of the chain, you cannot do anything about that. So the only thing we have seen in quite a low amount of chain is, like, the foundation got the fund and delegated quite nicely to everyone. So it will be, like, something like 2 or 4% of the chain to everyone. So it's quite, like, I don't know if you look at it, but for example, in Sentinel, in the Sentinel blockchain, it's quite, like, well reported. And if you see, like, some chain like Kava, not to say, it's only, like, Kraken or Binance, and it's literally, like, the centralized exchange that got most of the power. So it's not, like, quite properly balanced. But it's a team decision. Like, you cannot do anything about that. So as a validator, on our side, we try to just, okay, yeah, we're not gonna lie, we try to invest on the good protocol we like and be on the top. So people just know us and we are supporting the project, we are working on it. But yeah, it's totally depend of the foundation.
Yeah, like, the barrier of entry is actually not that high. Testnet. Go to testnet, operate on the testnet, period. Like, if you are an individual person who's interested in a project, like, you know, right now, Namada is running testnet. Right now, Penumbra is running testnet. Right now...
Once the chain's live, though, the barrier can be super high. Like, the Atom seed price is like $15 million.
Oh, Celestia testnet is running right now, right? And so my point being is that, like, look, like, you look at Polygon, right? And, like, there's proof of stake. There's, like, 150, right, validators that are allowed right now. And, like, the last one, like, no 150 is, like, it's like offline half the time. Like that's the barrier of entry is, right? And so like if you are there at testnet and there's a new project that you really like and you want to be involved in like their ecosystem, you're active in the Discord, you're active in like the Telegram chat, you're running testnet, they know who you are. And ultimately like these like teams, like they want to have people who are actively engaged running, and they will delegate foundation tokens to you if you ask them to. And so like it's not that hard to like get involved if you want to. You got to get up and like bootstrap yourself a little bit and then like do the work.
Yeah, if you are just like trying to create your brand and get on the active set, it's a fucking war, man. You have to go deep, like literally like talk to them every day and go hard and literally it's commercial things, like it's a business.
Yeah, it's a business. And the other thing I would say is like that Figment will help. Like we will absolutely help you.
Right, let's hear what Felix has.
Right, sorry.
Thank you.
Oh, yeah, I think, so I think in general, right, this is a problem that happens in many places in the world where the people in power get like lazy and they shift the money between them in a way. And I think the Cosmos ecosystem is like nicely designed to kind of disrupt that by being like many chains and like kind of evolutionary from the ground up, where new chain will spring up and then there is a new opportunity for other people to get into power in a way, like what we're saying, right? You're going in this new ecosystem, you can establish yourself there, and maybe that new ecosystem will disrupt also like some of the older ones, because I guess there is certainly some dynamics where like also empires, right, get like power becomes corrupted, and the only way to kind of disrupt it, I think, is to move and like an innovation and start to kind of launch more chains, do more things, and hopefully try to like evolve the system through that. And
yeah, I think it's great that like for the early stages, like the people who are building the chain, running testnets, etc., are the ones getting delegation. That makes total sense. I think that's awesome. I do think there is a problem when a chain gets a bit later, gets bigger, that like it's hard to get into the active set, right? And I think that could be improved probably with more slots, right? So more validators in total, and potentially like liquid staking and other rebalancing things where people have nicer ways to spread their stake across validators. Yeah.
Awesome. I think that is. We're up. Thank you so much, guys.
Thank you. Thanks, Daniel.
Thanks. Nice. Oh shit, yeah, is that not? It's just the first line. Oh, it's cool. Alright. This is a clicker. Forward back. And remember to keep the mic pretty close to your mouth. Yeah, have fun. Alright. Guys, please get settled in for... I'm back in my MC hat. Get settled in for the next talk. So we have Thomas here, who's DevRel at Interchain, and will be talking us through cross-chain messaging with Interchain accounts. Please give him a warm welcome.
All right, thank you, everyone. Yeah, the weekend is almost there, but before we have that, we're first going to talk about cross-chain messaging with Interchain accounts. My name is Thomas. As said, I am the DevRels of the IBC team at Interchain. GmbH. And we are the team that is responsible for the reference implementation of IBC, which is the IBC Go implementation. And I want to talk to you about interchain accounts today because we got some feedback from the ecosystem that there's still some confusion about interchain accounts and all of the terminology. So what we're trying to do today is to make that a little bit clearer and hopefully to kickstart a conversation because we're obviously open to feedback from the ecosystem to see if there's anything else we can do to help to make things more clear. All right. Actually, today at this event, I don't think I will have a very hard job telling you what IBC is and why it's useful. But still, I think it's always good to stop and think, okay, what are we doing and why are we doing it? IBC is the Interchain's universal general purpose interoperability protocol. And if you ask why you use IBC, I think you can make the distinction, why do we need interoperability at all? And I think it's pretty clear at this stage of the crypto industry, the blockchain industry, that there's not going to be one chain to rule them all. So we have different ecosystems, and obviously for developers, it's very useful if we can have interchain functionality and applications, right? So why pick IBC over competitors? There's a whole bunch of reasons, but those three are quite important. So we have security and permissionlessness. So basically, IBC is a protocol that works with light client verification. So that means that we don't need to rely on intermediate trusted parties. For example, other bridges employ like multisigs, which is a lot less secure and also permissioned. But actually relevant for the talk today is the third one, which is that it supports generalized message passing. And let's go for. So first, a little bit of context before we dive into interchain accounts. Maybe one more thing about IBC that is interesting to note is that you can kind of split it up into two distinct layers. So first we have the transportation layer, which is also sometimes called TAO layer, which stands for transportation, authentication, and ordering. And basically that is what ensures that we can send over packets from one chain to another chain. And the actual data that we send over, the transport layer is opaque to that. So it doesn't really care what data you send over. And this is the concern of the application layer. And most developers that will be working with IBC probably will be application developers. So they are concerned with the encoding, the decoding, and the interpretation and subsequent execution of logic based on what that packet data is. Right? So for the context and the history, last year in April, I think, IBC was launched live, and what it had in the IBC Go implementation back then was exactly this transportation layer, so packets could be sent, and one single application, which was ICS-20, the fungible token transfer. Now, fungible token transfer is very important for the IBC protocol, but as we said, it's not just a bridge that does token transfers. It is actually more than that. It supports generalized message passing, and this is why we will talk later about interchain accounts. But so the first application was ICS-20, the fungible token transfer, and let's take a quick look at this. So here we have two chains, A and B. A is the source chain. What happens is on the left, we see that some tokens are being escrowed on the source chain. Then in the middle, a packet is being sent. This is done by the relayer, who are responsible for ferrying these packets from the source chain to the destination chain. This is what happens in the middle. And then in the right corner, bottom corner, we see that there was a success. So there was a proof sent along with the packet by the relayer to basically allow the protocol on chain B, the destination chain, to check whether or not the commitment to send the packet and the escrowing of the funds on chain A was in fact committed. Now this slide I added because I wanted to make clear that token transfers is a very intuitive way to understand how IBC works. But actually, as I mentioned before, but it's good to emphasize it, the packet data is customizable. So you can send any type of packet data that the application developer chooses. So a very similar thing, I'm not going to go through all of the steps, but yeah, we see the source chain, the destination chain, the relayers, which are the important actors. And then maybe one more thing to notice that is important is that it's not always the case that we have a happy case where the packet is actually received. It could also be that for any reason the packet is not reaching its destination, and because we don't want packets to be stuck in perpetuity, we actually have a timeout functionality, and this means that if the timeout period has passed, the relayer can actually check on the destination chain for a proof of non-receipt, we call it. And if this proof is found, we can go back to the source chain, have a timeout packet message, and then the funds, for example, in token transfer, can be unlocked. All right, so enough about token transfer. Let's now go to interchain accounts. So as we said, we want ways to have random and arbitrary packet data being sent over IBC. And now, there's kind of two ways right now to do this, and that is interchain accounts, and we have custom IBC applications. And we're going to compare those two now. So first up is building custom IBC applications. Now, this is the more general one. As you can see, on the left, we have a blockchain which has an IBC module. Now, this is not the IBC core module that is present in the reference implementation. So if you spin up the Cosmos SDK blockchain, this will have already an IBC core module. But this module that you see, the IBC module, is the one that is being developed by the application developers. Excuse me. So here we see the relayer, and the important thing to gather here is that there is a lot of flexibility, a lot of customizability for the application developer, but it takes a little bit more time to get this going because we need to develop our own custom module, and at the top you also see ICS, which stands for Interchain Standards. So a standard has to be built so that every blockchain who wants to implement this application understands what is going on and that we have some specification. So this can take a long time. And so another option to send generalized message passing is interchain accounts. So if we take a look at this on the left here, we also have this IBC module, which there means actually the core IBC. And then we see on the left and on the right-hand side that it's a little bit more asymmetrical. It doesn't have to be, it could be symmetrical, but it allows for an asymmetrical design. And the blockchain on the left is actually called the controller chain. The blockchain on the right is called the host chain. So what actually happens with interchain accounts? I like to see it as the host chain, so the chain on the right, having some functionality that is native to the host chain, but that is not present on the controller chain. So the way I like to think of it is as kind of an API. So say I'm an application developer who develops an application on the controller chain. Sometimes I could want to use some functionality on the host chain, right? And you can think of an analogy in regular web development. For example, if you want to have a website, a web application that compares airline fares, you're not going to ask your user to go every single time to every website of the different service providers, ask them to fetch that data, and then compare only on your web application. What you're going to do is you're going to trigger an API, and you're going to look for that data from the API, send it over to your web application, and then do the custom logic. And a very similar thing is going on in interchain accounts. So now a little bit of a closer look at the architecture. So again, it's important to realize that there's two asymmetrical parts. So we have the controller chain and the host chain. Once again, it's also important to notice that you can implement both of these functionalities, or you can implement one of it. And as a matter of fact, nowadays in the ecosystem, we see that a lot of chains are in fact implementing host functionality. So they are allowing other controller chains to use functionality on their chain, but they are not actually using controller functionality. And we will see why this is. So once again, there, the host chain will host the interchain account and execute the sent transactions from the controller chain. The controller chain, so actions on the host chain, are being triggered from here, like an API. And actually, the controller chain has two main methods, which is register interchain account and send TX, but that will become clearer with this diagram. So once again, on the left here, we have the controller chain, so the chain that wants to implement some functionality from the host chain on the right. And here we see that actually what we implement in the IBC Go package is the ICS27 module. And this has submodules, controller and host. But what you also see on the left is that we actually need an authentication module that wraps this module. And this is kind of the tricky part, which means that the developers will have to develop this. But more on that on the next slide. Something else that we see is that we have the interchain account on the host chain. So essentially when we want to execute the logic on the host chain, what is being done is we simply create an account on that chain, and instead of using private keys to submit transactions, this happens programmatically by the ICS27 or interchain accounts module. Some other things is that originally we have a connection between those two blockchains, but if a module or a user wants to use this functionality, first we have to register this interchain account. It's not present from the start. And actually the authentication module, its job is to make sure that we manage the ownership of the different interchain accounts that could be created. And then the next flow, for example here, would be to have a sendTX. We actually updated the nomenclature. First it was called try-sendTX, but we thought maybe it's better to use sendTX, even though in reality, as I said earlier, things can time out, so it is actually try. We don't know for 100% sure that this will work out, but actually in IBC, there's like 90% success rate, I would say, so that's pretty good. And as I already mentioned, to go back to the current situation, and probably the reason we think that there's not a lot of controller chains out there yet, is the fact that you have to develop this custom authentication module. And we do have documentation for that guides you to this process, but obviously it's a little bit more work to do than, for example, with token transfer, fungible token transfer, where you simply spin up your chain, it has IBC, and you can send tokens over IBC. So one of the things that we're doing at our team right now is investigate if we can have a couple of templates that people can simply use and adjust a little bit, but basically make sure that there's less work associated with developing this authentication module. And let's look into some module templates, authentication module templates that we've considered. So one important thing that I also should mention is that when we developed interchain accounts, it wasn't so much the intention to make sure that every single user on one chain has an interchain account on another chain. That, for example, could be done by a multi-chain frontend, for example, right? It was really the intention that a module on the chain would create an interchain account on another chain and then use some functionality like an API. Nevertheless, we leave it up to the developers, and maybe some of the confusion was also because we have a demo repo, which we're going to take a look at later. And this actually uses the first flow. So the first flow is single user to single interchain account. Like we said, this was not the intended use case, also because for each interchain account you have to open a new channel, so this could potentially lead to a lot of channels being opened. Then we also have one-to-one, but here the contract, the interchain account, sorry, is rather a contract, so a smart contract. So this is slightly different and maybe could make more sense. Then we have few-to-one. In the Cosmos SDK's 046 version, we have the govs and groups module. So this actually allows a few users or a group of users to control an interchain account. And then the last one is ultimately what we had envisioned. So basically, many users go through the authentication module. The ownership of the interchain account is up to the chain or a module on the chain. All right, and now it's going to be the moment of truth to see if we can go to the demo. All right, there we go. So yeah, this is public, so you can also find it if you want to take a look after. Interchain accounts demo repo. So when we made this, this demo repo, actually our intention was to just quickly show what can happen, because as we said, if you don't have the authentication module, you can't really use it. So for demo purposes, that's not great, obviously. But basically, we're going to be looking if we can extend this and have the multiple templates. But what we're going to do, or what is being done if you copy all of the commands that are here, is essentially we're going to use the controller chain to delegate some stake on the host chain without actually having an interface or without having a direct message on the host chain. All right, so first what happens here is just some installation. Then we have make init, and make init is the difference between this where basically nothing is initialized. Make init will make sure that we build our binaries for both chains, start both chains, and have a connection. So as I said, initially there is no interchain account, so there is no channel. Then this is just to make our lives easier, just have some environment variables. Then the first step is to register an interchain account. So again, here it's simply the flow of one user, one interchain account. So one user can actually use the CLI commands based on this authentication module in this flow. Let's go a little bit further. To register an interchain account, and as you can see, we now have a channel that is live, and also we have the interchain account that has been registered. So if we are going to want to submit transactions with our interchain account, we also need to fund it. So this is what happens in the next step. And then we are mostly set up to send the interchain accounts transaction. So again, what we want to do is we want this user to actually make sure that there is a delegation to a validator that they choose on the host chain from the controller chain without having to change interfaces. And so here we have the commands. So what you see here already is that you simply include the data for the transaction. And then what happens is this flow. So remember what I said, the API is basically a registered interchain account and this sendTX. So the user initiates the sendTX, goes through the authentication module, ICS27 on the controller chain. Then in the packet, we include this transaction data is being picked up by the host, hopefully. Then we have execute transaction. And as you can see here, we have some stake to this particular validator. So this is just a proof of concept, but I think you will find if you do the demo yourself that it's actually pretty nice to see that you can do this and just have transaction from a user on one chain being executed on the host chain. And as we saw before, we'll hopefully have more of these demos that can ultimately lead to templates, and then we will hopefully see a lot of chains implementing this controller functionality, and we'll have a lot of interchain accounts, applications. All right, so that was my presentation. Thank you for your attention, and also thanks to the team here for organizing this amazing event. Thank you. Don't know if we have time for questions. Sure. Don't know if there are any questions. All right, cool. Thanks.
Cool. Thanks a lot. Yeah, guys, so I think we're done here on the Builder stage for today. Thanks so much for coming. There's a panel going on now on the main stage on the future of the Interchain. Should be interesting. Lots of big names on the panel. So yeah, thank you so much. Thank you to the team, Romain, the AV, sound, mics. It was perfect. Let's give him a big round of applause. Yeah, enjoy the rest of the day and see you soon.